in silver and gold. Turn to see through the haze, try to hear
Okay. Okay. Hey, good morning, everyone. Hey, welcome to the second day. I hope you guys had a great dinner last night and are all settled in. You may know today's keynote speaker from last year's Lxjs, where he created and performed a song using 5 mobile devices coordinated by Appium. You also helped me understand generators, thank you, and is director of ecosystem and integrations at Sauce Labs. So please give a warm welcome to Jonathan Lxjs. Thank you.
How about now? All right. Yeah, good morning. Glad to see that so many of you made it. I'm sure last night was really fun. I was up mostly working on my talk, but I was still up quite late. Yeah, I'm me. I'm JLips on Twitter, and I work for a company called Sauce Labs. I'm in charge of our ecosystem and integrations team, which means I help take care of the open source ecosystem around Sauce Labs and automated testing. Mostly I work on a project called Appium, so I can take my sunglasses off now, which I talked about at Lxjs last year. And I'm really proud that Sauce is sponsoring Lxjs again. And I also wanted to personally thank all of the organizers for the amazing job they're doing making this a remarkable conference. Last year, with their support and encouragement, I had the most fun that I've ever had giving a conference talk, and I'm really thankful to have the opportunity to hang out with you guys a second time. By the way, this song I actually have sort of a recording of. It's just an acoustic version, but I gave it to David, so you might hear it during some of the breaks if you liked it from last year. Well, this year I don't have a crazy software robot music demo. I think that's the kind of thing you can only do one time. Instead, I want to engage you guys with some questions I think are important for us to wrestle with. Something I love about the JavaScript community is that we take the time to talk about more than just programming. We don't always have a perfect dialogue about cultural issues, but I'm heartened that the dialogue exists somewhat. There are a lot of industries out there that I think you'd be hard-pressed to find even the barest recognition that its community consists of people and not just professionals. So I like that the JavaScript community and this conference recognize that we're human beings first and foremost, even though we're gathered here because of a shared love for programming and JavaScript. So here's my attempt to engage that aspect of our technological adventure that we're on together. I think what I have to say is best digested as a conversation, not a talk like this in a series of bullet points and slides. So I want these 20 to 30 minutes to be merely the first words of that conversation. I hope you'll listen to what I have to say, evaluate it critically, and find me sometime today or later this weekend to continue the dialogue. All right, enough preamble. I want to talk to you guys about the philosophy of technology. Philosophy and technology are both long-term loves of mine, but it's only recently that I sort of realized or was made aware through reading different books and things that you could put them together, that philosophy of technology was an actual thing people talk about. Of the two, technology came first for me. Let's talk about JavaScript specifically, since we're at Lxjs. I wrote my first JavaScript code about 17 years ago. I actually went back on my computer and looked at the timestamp on the file, because I still have it. I needed a scrolling ticker for a welcome message on my website, which is a canonical use of JavaScript about 17 years ago. And when I say wrote JavaScript, I mean copy and pasted from somebody who knew how to program. It wasn't really until about 12 years ago that I wrote my first JavaScript program from scratch for myself. It was this supremely customizable JavaScript-only drop-down menu script. And I even made it open source, though I didn't really know what that meant at the time, other than that it made me a hacker or something. When I got to university, instead of studying computer science as I originally intended, I chose to pursue philosophy, because I was curious about the biggest questions that it was possible to ask. Questions about God, the nature of reality, the nature of science, how we truly can say that we know things, and so on. Of course, there's not a lot of job opportunities as a philosopher, so I ended up becoming a programmer by trade anyway. Turns out you don't actually need a computer science degree to do that. One thing I learned from philosophy is how to approach questions, asking questions. Another thing I learned, which any of you who've had a philosophy course can probably corroborate, is that there are always more questions to ask. It can, in fact, start to feel a little disorienting when you've asked so many questions, like the rabbit hole just goes on forever, and at some point, shouldn't we just get back to doing real work, like programming? Well, I think sometimes this otherwise praiseworthy pragmatism can leave important issues unexamined. And as we all know from the Socrates quote, the unexamined life isn't worth living. So today I want to ask, what have we left unexamined in the pursuit of our technological careers? What has the world left unexamined in its wholehearted and wholesale adoption of technological solutions to nearly every problem? Quite a lot, I'd argue. But now I just want to focus on two areas of modern technology, two buzzwords which are familiar to us in our community, in which we're even talking about at this conference. The first is the Internet of Things, and the second is the quantified self. So what is the Internet of Things? In my understanding, it's the concept that everyday objects, things which have not traditionally been considered computers, can and should be connected to each other, networked in order to enhance the benefits that they provide us. Another way of looking at it is to say that it's the process of turning things into devices. So now's a good time to introduce my favorite philosopher of technology, a professor at the University of Montana named Albert Borgman. Part of Albert Borgman's take on technology is that there is a deep and significant divide between things, capital T things, and devices. And this distinction is so important that for him, technology itself is characterized by what he calls the device paradigm. Now, I'll explain what he means by the device paradigm in a moment. A central question in the philosophy of technology is whether technology should primarily be thought of as a contentless tool, which gains significance purely through the intentions we, as the tool users, give to it, or whether it has a character of its own, independent of how it's intended to be used, what we intend to do with it. In other words, is technology more like an axe, which is a tool that can be used for the beneficial purpose of chopping firewood and the horrible purpose of murdering somebody? Or is technology more like capitalism or socialism, a large system which shapes and colors every action that takes place within that system, no matter the intent behind the action? Most people like to think of technology purely as a tool, that we can appropriate it for good purposes or bad, but technology itself is neutral. It doesn't really have a character of its own outside of the purposes that we put it to. But Albert Borgman has a strong argument that this isn't actually the right way to look at technology, and it involves this device paradigm that I mentioned earlier. Borgman claims that technology can best be understood and explained by looking at canonical examples of technology, in other words, a paradigm of technological devices, and noting what these all have in common, what the most important features of all these things are. And what they have in common is the attempt to make a certain good available to us in a non-burdensome way. So what do I mean by that? What I mean by good, in this case, is just something that's necessary or desirable for human life. Food, drink, safety, entertainment, shelter, all those things. And what I mean by available in a non-burdensome way can be cashed out in terms of 4 different requirements. First, let's give an example to talk about what these requirements are. Let's say the good that we're talking about is the good of heat. In many parts of the world, some form of non-naturally occurring heat is an essential part of our daily existence, especially in wintertime. Now, we can think of different ways of procuring for ourselves this good of heat. A pre-technological way would be to light a wood fire in a stove in our hut or something, or in our cabin, in our house. Whereas in our modern society, a technological example is a kind of electric or gas-powered central heating system, like most of us enjoy in our homes. It's probably obvious that a fire is not available to us in a non-burdensome way when compared with a central heating system. So let's go through these 4 aspects of availability to talk about why. First of all, for something to be truly available in this sense, it needs to be instantaneous. Wood isn't instantly available to us in burnable form. We need to chop it, we need to gather it, and this is a hard and time-consuming process. A central heating system, on the other hand, begins to provide heat as soon as we flip a switch or turn on a dial. It's instant. Second, perfect availability requires that a good be ubiquitous, meaning that it must be available everywhere. A wood fire does not meet the standard here in the sense that when it provides heat, it does so in a limited way, only in the vicinity of the fire itself. It's uneven. It's not equally distributed across the entire house. Whereas a central heating system uses a system of ducts and vents to ensure that the entire house can benefit from the heat. So the third requirement is that for something to be truly available, it needs to be perfectly safe. Wood-burning stove is far from safe. Working with the tools required to chop wood can be a source of serious accidents, and of course fire itself can be a cause of burning down your house, causing death and destruction, as used to happen, probably sometimes because of wood-burning stoves. A central heating system, on the other hand, is relatively safe. We can leave it on for months or years without worrying that it's going to burn down our house. Okay, finally, for a good to be truly available, it needs to be delivered easily, without a lot of physical or cognitive effort. It definitely takes a lot of effort to prepare, use, clean a wood-burning stove. Never mind the effort to chop and stack the wood in the first place. And it takes mental effort to remember to check the stove, keep it heating optimally, make sure it's not burning down your house. Central heating, on the other hand, is so easy to use that many of us forget that it's even a part of our daily existence. We can set it on a program that matches our heating needs and not think about it ever again, unless it happens to break down. So this is the foundation of the device paradigm, the process of making goods available to us in a non-burdensome way. And indeed, this has been precisely the promise of technology since Descartes dreamed about what control of the physical environment would allow us to achieve. This is before the Industrial Revolution. The elimination of burdens and dangers that make life disagreeable and unpleasant. He predicted that once we gained enough control through the natural sciences of our surroundings, we'd be able to make everything available in this way. And it sounds like a reasonable, laudable goal, right? And I won't argue that it's not. But I think it's important to realize 2 things about it. First, this is the very DNA of technology. It's not just some incidental aspect of it. It's a philosophical stance at the very core of the technological enterprise that this is what matters. So everything technology touches, everything we do with technology is going to be shaped according to this philosophy. In that sense, it's not true that technology is just a neutral tool. It has a definite character, and that character is the continuous attempt to make goods available to us in a non-burdensome way. Secondly, and I think more importantly, this focus on availability for availability's sake leads inevitably to a rift down the middle of things themselves. A division of a thing, which before was just a whole entire thing, into a mechanism and a product. So let's go back to the example of heating. In pre-technological eras, it wasn't possible to distinguish a good, like heat, from the way that good was procured. In the middle of a cold winter, it wasn't possible to have heat without a fire. And it wasn't possible to have a fire without firewood. And it wasn't possible to gather that firewood without going through the laborious process of chopping up trees. So staying warm was inextricably tied up with this direct physical investment of time and energy. You couldn't separate it. They were one and the same thing. But once we have enough control of nature, we can produce heat without firewood. We can begin to think of heat as something on its own, a commodity, as something independent of the way that it's produced. And once we do this, we can begin to care progressively less and less about the way that it's produced, until we wind up with the current situation where we enjoy central heating in our homes without having any idea how it actually works, and it doesn't matter. If central heating technology changed tomorrow to use a completely different method of heat production that was equally available, safe, all those things, and someone installed it in our house without telling us, we'd probably never even notice. What matters to us is the commodity, the good that's produced. So let's look at another common device as an example, a television. What's the good or commodity that a television provides us? Well, embedded in a larger cultural context, it's entertainment or information, something like that. But purely as a physical object, the good that it produces is the clarity of representation of a moving picture. So what we'd predict on the basis of the device paradigm is that the physical construction of a TV might change radically over the years, but the salient bit, the screen, the part that's most directly related to providing the good, this clear picture, would change basically only in one way. It would become clearer and more prominent. And this is exactly what we find. Early TVs were mostly bulky objects with a small, distorted black and white screen. And through a variety of vastly different picture-producing technologies, mechanisms, we've gradually evolved to where we are today. We have these large, flat TVs where it's almost not possible to see anything other than the screen, which is amazingly clear and sharp. And we don't care that our TV might use a liquid crystal display rather than vacuum tubes. And if this technology changed tomorrow to something cheaper or easier to manufacture, hardly anyone would even notice, as long as the screen stays the same. We don't care about the physical bits of the TV, we care about the picture. So the point that I've been trying to make is that devices don't have a single essence. They have a divided essence, two aspects, halves or layers. One aspect is the thing the device does for us. Its commodity, its good, its function. The other aspect is the physical stuff of the device itself, the arrangement of silicon and metal or whatever that enables the device to live out its function. And this can be replaced time and time again without changing our appreciation of the device. The form, in this sense, doesn't even really matter. The stuff that makes up the device isn't what's important to us. It's the function. Another way of looking at it is that there's a distinction between means and ends in devices themselves, what the device is for and how it does what it's for. Now, this all might seem obvious and natural to us, given that our world is full of devices, but this distinction, this way of looking at things, is actually radically new in the history of technology and the history of humanity. In the pre-technological era, you couldn't have heat without a stove or fireplace in your room. You couldn't have music without a musician and an instrument. You couldn't enjoy a dramatic performance without the actors being there in front of you. Okay, so what? What's wrong with making the ugly parts of a TV less prominent and the screen more prominent? And the answer is nothing. Nothing's wrong with it. The sole purpose of a TV is to provide a full, clear picture. And so the ideal TV is pure picture and nothing else. The problem comes in when we use technology to make goods available to us which were once delivered through a deep engagement with the natural world or society. and which often brought along intangible or unquantifiable goods with them as part of the process. To think more about that, let's go back to the example of the wood-burning stove. So a wood-burning stove gives us the good of heat, just like a central heating system. Now, it had all the drawbacks that I mentioned earlier in terms of availability. It wasn't safe, it wasn't ubiquitous, it wasn't all these things. Compared to a central heating system, chopping wood and keeping it burning in one room of the house is an awful lot of, to us, wasted energy and work. It was very burdensome. It was very laborious. So along with this tedium came some benefits, though. Gathering and chopping wood served as part of the daily rhythm that served as a reference point for the day's activities. The fact that the heat from the stove was available in only one room of the house meant that the entire household or community would gather in one place for the evening to be by the stove. They would experience together whatever that evening held, whether it was reading, music, discussion. Well, let's take another example, that of food. Food is certainly a good that we would like to be more available in the sense that I talked about before. Its lack of availability in many parts of the world is a cause of death. And indeed, we can make it technologically available to our societies once we're sufficiently advanced. So let's take the example of a frozen TV dinner. It's probably the easiest example to think about. The promise of a frozen TV dinner is to deliver the twin goods of nutrition and flavor, the goods that we've always tried to get out of our food. And it tries to be reminiscent of an actual freshly prepared meal, but without the inconvenience of growing, harvesting, and cooking the food yourself. It's food turned into a device, instantly available. But of course, for most of human history, enjoying the good of a meal was inextricably linked to engagement with the earth through farming, engagement with the community, engagement with the tradition of culinary arts, and finally, celebration and conversation with the others who were also at the table. But for the sake of availability, these less quantifiable goods have been replaced by technological mechanisms that make it possible for TV dinners to exist. Industrial agriculture, chemistry, food science, and so on. So through technological innovations like central heating and instant food, we've figured out a way to deliver to ourselves what we thought we always wanted in terms of the goods of heat and food, but as a result of them becoming technological devices, we've ripped them free of the things and practices that used to be necessary for us to enjoy them. And it turns out, I would argue, that some of these things and practices, like certain kinds of manual labor, engagement with and knowledge of the natural world, the skill of cooking, or the celebration of a community, are really important for us as humans. I don't think this is the fault of technology, as if technology were some person out there trying to destroy what's meaningful about human life. But I do think the device paradigm encourages us to think more and more in terms of means and ends rather than unified wholes. More and more in terms of devices rather than things. More and more in terms of quantifiable commodities rather than qualitative or unquantifiable goods. And more in terms of individual consumption rather than collective creativity. So let's bring it back to the Internet of Things. Am I saying that the things in our lives shouldn't be more connected? That we should stop writing JavaScript to control physical hardware? Otherwise, we'll ruin society? No, I'm not saying that. I'm simply trying to get us to recognize that the driving force of technology, the device paradigm, entirely ignores the hard-to-define, unquantifiable goods that make up human significance. I want us to ask a few questions before we wave our magic technology wand over something that looks like a problem, to make sure that in solving it and making a good more available, we're doing so in such a way that leaves us just as human as we were before. Speaking of being human, let's talk for a minute about the quantified self. The technologist Jaron Lanier, I'm not sure how to say his name, has a great book called You Are Not a Gadget that I think addresses this particular topic in a much better way than I can. All I want to say is that I fear the quantified self movement will lead to treating human beings as devices rather than whole unified persons, rather than things in ourselves. And of course, historically, treating humans as anything other than persons has had disastrous consequences. Now, don't get me wrong, I love data as much as the next nerd, and I was initially inclined to jump on board this bandwagon. Track my runs so I can create reference points and understand my progress. Track my sleep so I can adjust my life to get better quality rest. Absolutely. And I think these things really are positive. The danger here is that it encourages us to think of ourselves in terms of a conglomeration of statistics, in terms of quantifiable information that can be neatly categorized, filtered, and sorted. But we're not like that. It encourages us to think of others in that way as well, opening up infinite opportunity for, I would argue, unhelpful and meaningless comparison between ourselves and others. We quantify ourselves for the sake of software these days in a lot more ways than tracking our biological metrics. Every time we select a choice from a drop-down menu or select box on a social networking site, we're choosing to present a squared-off, low-fidelity version of ourselves. I don't need to tell you that the common task of choosing a gender from a select box can be an extremely self-limiting experience for many people. But computer programs ask us to circumscribe ourselves in many more subtle ways. Just because it's convenient for computers to think in terms of binary or mutually exclusive categories, just because it's convenient for database queries to filter based on preset options, doesn't mean this is a good way to model human behavior or relationships. But we as humans are really good at adapting, and we've been really good at adapting to what has been technologically feasible or technologically easy. The result is that we've grown to be more like computers in our self-understanding and self-description rather than the other way around. Did it have to be that way? No, I don't think so. And I have hope that once we stop lowering our standards to deal with computers, we'll develop apps that we put a lot more humanity into so we can remain human while using them. Okay, in wrapping up this part of my talk, I want to reiterate that I am actually a technologist, a proponent of technology. From the time I was young, I've been impressed by the power of technology to change the world. I was really excited about the possibilities for creative expression that it opened up for me as a kid and last year. I loved writing code to play music on mobile devices for you guys. And I'm not trying to get you all to stop hacking on connected devices or social networks. What I'm trying to do is get this community to start looking at technology not just as a tool, not just as the obvious solution to the world's problems, but almost as an entity in its own right that has its own characteristic way of operating. I think we really need to know ourselves before we can engage with technology, or we will find ourselves and our technological creations unwittingly reshaped by it in ways that we might not predict, ways that might have unintended side effects. We need to decide for ourselves, in essence, what it means to live well as a human being. And this, of course, is one of the classic questions of philosophy. What is the good life? And I'm certainly not going to try and come up with an argument about that here. I did give some hints along the way of what I think might be involved, and I'd love to engage you all in further conversation about it. But the point is that we need to go down that rabbit hole for at least a little bit if we want to answer the questions I'm raising about how we go about developing technologies that augment and ennoble human persons, rather than diminishing and demeaning ourselves and our neighbors. Well, I wanted to leave you guys with a concrete experience to accompany the very philosophical and abstract nature of this talk. The most symbolic thing I could think of to do is to write and play a new song for you guys. It's a song that I wrote with the theme of this talk in mind. I wanted to capture the idea that there's something unique about this physical experience that we're sharing together. especially when it comes to music. I think shared physical experience is very important. In the future, I might record this song. I probably will. And through a number of takes and attempts at recording it, I'll probably capture something that I think is maybe a perfect performance or a perfect recording. But I think that the minor variations and even missed notes and forgotten words in this live performance can combine themselves into an unrepeatable perfection of a totally different kind. And that's what I'd love for you all to experience right now. So I wrote this song on an instrument that I've barely ever played before. Apparently it's a Russian instrument called a domra. Are there any Russians who can validate that that's true in the audience? Is this in fact a domra? It's true. All right, good. My dad gave it to me as a gift when he came back from Russia like 20 years ago. I was a child. I didn't even know how to play guitar at the time, and I never really figured out what to do with this. But I got it out of storage a few months ago, and I've really been loving the sound that it has, so I've kind of taught myself how to play it. I don't even know if it's tuned in the traditional manner. It has a great sound, and I wanted to play it for you guys. Also, I could fit it on the airplane much easier than a guitar. So I'm also going to do something a little different during this song to try and engage all of you, so it's not just a passive listening experience. So I have a URL on the screen, and I'd love for you all to go there now on your laptops or mobile devices, and hopefully we don't oversaturate the network. If you have a mobile device that's on the cellular data, maybe use that instead, so people who only have laptops can use them. It should work on a mobile device too. It's a very small app that asks you to enter one word that describes how you're feeling. And notice that it's a text field that allows for arbitrary input rather than a select box. Well, I thought we could try an experiment together to make this experience even more unique. As I play this song, I want you to submit the words that you've chosen to describe how you're feeling. It only lets you submit one word, so no phrases or things like that. And the words are going to be animated on the screen up here in real time. You can update the words in real time as well, so if your feelings change over the course of your song, you can create new words. But I have two simple and serious requests. One, please be honest. I think this experience would be lessened by jokes or dishonesty. And secondly, please don't be a troll. I know that anonymity on the internet means that someone is going to write something obscene. But I have higher expectations of this community. So I'd love to have you experience this with me in a real way. So thanks for listening. I'm going to, I guess I should fill out how I'm feeling too. Maybe I can go full screen. Well, right now I'm feeling a little nervous. Okay. Wow, you guys are fast.
My eyes falter, drop their gaze. I cannot see things anymore. When will you come to me? When will I know your name? When will I feel that this is a solid truth, planted in solid earth, something I can't exchange for a newer model that's in a box, planned obsolescence in my soul. Oh, when will you come to me? When will I know your name? When will I feel that this is real? There is life in our difference. Bring out what I cannot know of myself, but the mountains have been made low, and the other are gone from experience. Do 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 When will you know your name? When will you come to me? When will I feel that this is real? Ooh. There was a meaning here, I swear, but I can't see it anymore.
Thanks. Wow, that was fun. Thanks for letting me do that. How do I get back to my thing? No. Okay. Good thing it didn't crash earlier. That's awesome. Last slide. First of all, thanks for experiencing that with me. I didn't notice any particularly obscene words. Someone did write bacon, which is a pretty good way to feel sometimes. I take that as a compliment. Here's some resources if this topic interests you. A couple books that I mentioned, Albert Borgman and Jerome Lanier, as well as my blog where I've tried to write about this stuff, trying to write about it more frequently. And then the Meteor app, it's a Meteor app that I created for this live experience, is also open source, so it's up on GitHub. So if you want to go play a song somewhere and have people write how they're feeling, feel free to reuse that. Take a look. All right, well, thanks a lot. I'm very excited for the rest of the day, and yeah, enjoy the rest of the conference.
Please help me welcoming out of Redwood City, California, Kevin Sawicki.
All right. Hello, everybody. Can you hear me okay? Perfect. All right. So, as was said, I'm Kevin Sawicki. First, I wanted to show you the GitHub team if you've never seen everybody before. We're based out of San Francisco, California, and this is roughly 250 of us up on a little roof somewhere. And I just want to extend anyone an invitation here that if you're ever in San Francisco, the Bay Area, or California, and you can stop by, I'd be more than happy to have you at our office for the day. You can work, hang out, have lunch. So if you're ever in the area, feel free to shoot me an email, come by and meet all of these wonderful people. And if you're trying to find me in this picture, I know you're all like, where's Kevin? I'll zoom in a little bit and highlight myself. I'm right back there. So that's where I was hanging out that day when we took this one. And here's a better one of me with my lovely dog Franklin. So if you ever came by, you would see him running around the office there. And you can find me at Kevin Sawicki on GitHub, Kevin Sawicki at Twitter, and if you want to send me an email, old-fashioned style, kevin@github.com works. And a little bit more about myself. I've been at GitHub just over 3 years now, and I've done open source my entire time there. So every line of code I've ever written in 3 years at GitHub is open source somewhere. I started out working on JGit and eGit. So JGit is the implementation of Java, or the implementation of Git in Java, and eGit is the Eclipse plugins to do Git-related things. After that, I moved on to working on the GitHub Android app that we released just over 2 years ago now, and after getting really sick of Android app development, I moved to the Atom editor, which is where I'm really happy to be. And so throughout this presentation, I'll have these space-related images in all the backgrounds, and I just want to give a shout out to NASA for making these images all available. So if you're ever looking for really great, nebulas and galaxies for your slideshows, this website has a new picture every day that they post of all this crazy, awesome telescope renderings and whatnot. And so kind of on to the 10 things about this presentation. The first one is that Atom is a text editor. So how many people here have already used Atom before today? Great. So you hopefully know this already, so I'm happy to hear that. So it's not a JavaScript IDE and doesn't really have ambitions to be an IDE. It's a text editor first and foremost, and that's its kind of goal and mantra. And so what is a text editor, right? It can kind of be summarized in a really simple kind of principle that really can be extended to go way further as they evolve over time. So first, you press a key, right? You download a text editor, you open it up, and you press a key. And now what happens, when you press that key appears on the screen. And that's the essence of a text editor, right? You press something, and then you see what you press. So I know you're asking yourself then, what do you do next? You repeat. You press a different key. And this step alone that you perform, I don't know, you probably say 1,000, 10,000 times a day, is where a good text editor is separated from a great text editor. Because a good text editor, or a great text editor, makes this action put the least physical and mental strain on you. And the mental strain being, is the text editor slow? Does it feel like it's slowing me down? Is it doing things? Is it rendering things incorrectly? Is it highlighting words correctly? And the physical strain being, are the keys and the shortcuts all in intuitive places? And can I type all day, every day, without feeling tired? Because everything is architected to put the least physical strain on my body as I type text all day. And if we give a quick demo of Atom, you'll see that it does just that. In this recording, I am pressing keys, and lo and behold, those keys are appearing on screen. And this took 3 years to get to this point in time. So I don't recommend building a text editor unless you have 3 years of time on your hands. The next thing that we're really, really excited about is that Atom is open source. And so if you may remember, we beta launched in February, so right at the end of February, we did an invite system where, we sent out invites and you could send your friends invites and you could download Atom, and it was free during the beta, but the code wasn't open source. And a couple months later, we're able to, fulfill that commitment and open source all the repos, 100% of the code, the app framework that we built to build the text editor on top of, and all the packages are now open source. And so you can go to atom.io, download it, see all the docs, and then also if you want to see how the sausage is made, you can go to Atom and see all the code for the editor, as well as we have another couple hundred repos under the Atom organization. And also we have a Twitter account where we rarely tweet, but it's useful information. So keep moving on. Atom is built on web technology. So if you've used it already, you may know this, but it's kind of nice to go through the stack of Atom to kind of feel through what we built it on top of, and if you're interested in hacking on it and becoming a part of it, what you would need to kind of use to extend it. So at our very core at the very core of Atom is node.js. So any node module out there you can use for your Atom packages. You have access to all the full node APIs, and Atom is built around that as its core technology platform for reading and writing files, network stuff, all that. But we also have a real heavy dependency on Chromium. So all the rendering that you see inside of Atom is Chromium, right? We use a project called BrightRay to embed Chromium in a native app. Similar in a lot of ways to the Node WebKit presentation yesterday. It's this nice event loop hybridization of Node.js and Chromium. And getting a little more detailed, we use Grunt right now for all our build system to build the app, to compile things and all that fun stuff. So we're fans of Grunt. And we also do a lot of CoffeeScript. So if you looked at the Atom code right now, you would see 100% of it is CoffeeScript, but there's no hard dependency on this. You can write any Atom package in JavaScript. You're not forced to use CoffeeScript. We just use that to build the core editor and all the core packages. Unsurprisingly, we use Twitter Bootstrap for all of our basic UI controls. So if you were looking to add some buttons or some panels or menus, Bootstrap is built in, so your Atom package has immediate access to that. And we use less for all of our style sheets. So if you're looking to ever write an Atom theme, we have all these variables defined, so you can write a theme with a very minimal amount of effort. You can just say, I want the background of strings to be this color, and I want the cursor to be that color. And we use less to give us, just support for mixins and variables inside the CSS that eventually gets generated. And the last piece is really Jasmine. So we're really big on writing specs for the editor and making sure that all packages are well tested, and we use the Jasmine library. And Atom actually ships with the spec runner. So if you have Atom open right now and you want to run all of the specs that ship with it, press Command, Alt, Control, P. And then all the Jasmine specs for Atom will run. Hopefully they all pass on your machine. And so you can immediately start hacking on Atom and making sure that the tests pass if you have a package you're developing or you're trying to add something to core. Another exciting piece is Atom is cross-platform. So when Atom first came out, it was Mac only. We only had Mac builds, and we still only have official Mac builds. But I am happy to say that we've come pretty far in the last couple weeks in getting Atom to be very consistent on Linux, Mac, and Windows. And we're really close to having official Windows builds out, although I see a lot of MacBooks here, which is exciting, because it's definitely the best on Mac still. But there are several Linux distros that now have access, that are in the process of adding Atom support, and so you could just install it using any package manager. And so an interesting stat is last month, 5.5 million files were opened in Atom, right? And we use Google Analytics inside of Atom to report anonymous usage statistics to allow us to kind of see what features are getting used and just how prevalent Atom is getting used. And that's a really great number, right? That's a lot of files, right? That's a lot of files that got opened just in the last month, and that number is kind of like doubling every month. But you can see we're still a long way away from being kind of representative of the typical platform breakdown, right? We have 90% of those files were on a Mac, a little under 5% on Linux, and 2% on Windows. So we're really not far getting people on Windows to adopt Atom yet, and so that's what we're working on really hard right now, is making it easy to install on both Linux and Windows in the same way it installs on the Mac. So our most exciting thing about Atom is we call it the hackable text editor, and what that really means is that with very minimal effort, you can get Atom to do what you want it to do. So whether you want to remap some keys because you like different shortcuts than we ship with by default, whether you want to change some styles, or whether you want to just hack on any sort of interaction with how tabs get opened, how files are browsed, how the autocomplete shows up. And we give you access to every single API and the entire DOM, of course, to kind of put your stamp on Atom as you're running it. And the exciting part of building on top of Chromium is that we have the dev tools available to us, which make text editor development so much better. And so I can use all these Atom APIs to kind of give me the text of the current open editor that has focus, right? I can also just call any random node code. I can require FS and read the user's dir. And of course, I have the full DOM access as well, so I can poke around and see what styles are being used in the active editor. And this is amazing, because if you think about a lot of the native apps you use, if you wanted to actually develop them, you'd have to rebuild them with some dev flags or download some other developer tools. But the Atom dev tools are always available, always on. You can, if you think you found a memory leak, you can take a heap snapshot and email it to us, and we'll be able to pull it in. And so it makes for a really hackable editor when nothing is off limits, and you have these amazing tools like the timeline and the flame graphs and all these other things to profile your application and make sure it keeps up with you as you're typing. And so the bare minimum you need to hack on Atom is a very simple list, right? It's going to be a little HTML, right? So we have HTML5. You can do WebRTC, a lot of the cool new things that Chromium allows. We have all of those enabled. You can also change Chromium flags if you want to experiment with bleeding edge stuff. At the bare minimum, there's going to be some JavaScript involved, right? Although we use CoffeeScript, if you're into JavaScript, go for it. That's all you need to kind of get started hacking on Atom. Of course, CSS, like I said, we're using less, but it's really just for variables and mix-ins. But you can use all the fun CSS stuff to theme and control Atom and kind of make it look appealing to you. And then, of course, having Chromium at its core, we have access to all of those APIs that are available. And so it makes it really great to target just Chromium and use all the bleeding edge stuff when you're trying to hack on something that helps you be more productive as you type text all day. Moving into that, we like to say Atom is stylable, right? So we ship with a couple default themes, a light one and a dark one, but we really want people to make it really comfortable for them as they develop. So whether you're a huge fan of dark on dark and you don't work in glare, so you can do that all day, or if you're outside, you can easily get a theme that kind of helps you in any sort of brightness environment, and also hack on it to make it the custom tweaks to get it looking like you want it to look. And so as Atom has all these config files and these local style sheets, and as you edit them, Atom is actually watching them on the file system, so you can actually kind of hack on the Atom styles as you're in Atom, so you don't have to restart or download any developer tools. If this is just one Atom window, and on the left side I have one file, and on the right side I have my local style sheet, which is stored in your .atom folder, and you can see as I change these colors in the less file, the code immediately updates on the left because we're always watching for style sheet changes, and we re-render the editor whenever that happens. And so it makes it really easy to kind of take the default the markdown styling and just tweak the classes to make it more conducive to terrible purple and yellow colors. And so Atom is also all about packages. So that was kind of core to the editor's architecture is a really small editor component at its core and a pane system for splitting and moving editors around and a low-level text buffer API, but that everything else, all the other functionality you see out of the box is provided by the packages that we ship with that are, we roughly ship with 80 packages built in. And so when you look at a screenshot like this, right, you'll see, it looks like a basic text editor, right? I have some text, I got the line number, I got the tabs, I got a little status in the bottom. But this is really a whole set of packages working together to kind of deliver this out-of-the-box experience with Atom. And so if we look, to the left side of the editor, we see, we have some colorization of lines 1, 3, and 5, right? And that's actually this get diff package that's telling me that those lines have been edited but not checked in yet, right? And then if we look up top, this is actually the tabs package. So tabs aren't, built into Atom's core, the UI that it delivers out of the box. It's actually a third-party extension that renders a small div at the top of the screen and listens for active editor changes, and then just makes the active tab match the active editor. And then if you can see, in very faint on the right side, we have like a vertical line at the 80th column to help you wrap. And that's not built into the editor either. That's a third-party package that just renders this line at a configurable column that you can say, like, in Objective-C files, I want it to be at 120, but at JavaScript files, I want it to be at 80, and that's also a package. And then if you can see where I have my cursor on the curly, you can see that the other curly is highlighted yellow, and that's, again, another package called the bracket matcher. And so if you wanted to tweak that behavior or add custom matching, you would just explore the bracket matcher API. You can fork it, open a pull request, and get it to work the way you want to work it. And then also in the screenshot, we have the status bar package, which is a package that other packages can extend to throw things like the cursor position, the file name. If you look at the bottom right-hand side, you'll see there's other git diff information, the number of lines added and deleted since this file was last committed, and also the branch I'm currently on. And then we have this package that allows you to, I was one ahead on here. We have this package called the grammar selector package that puts the active grammar name, and so if you wanted to change the syntax highlighting, you could just click it and toggle it, and it would edit it. And the really cool part of this, the reason I kind of wanted to show all these packages in motion is that with a simple configuration like this in Atom, you can disable them all, right? So anything you hate about Atom out of the box, you can immediately turn off or re-implement yourself or install as a fork of these packages. And all it is we have a very simple config file, and you can just say that all these package names I want disabled. And what would your Atom look like if you did this? It'd be a little more Zen mode, right? There's not as much noise, there's no status bar, there's no tabs, there's no decorations, but it still works. There's no assumptions about all these, out-of-the-box features that can all be independently disabled and turned off. And so where are we so far? We have 900 packages that have been published by people that don't work at GitHub since we launched in February, which is amazing. Another amazing number is 300 themes, right? So that means almost every theme that's ever existed for like Sublime or TextMate or VI or Emacs has probably already been ported to Atom. So if you're looking for it, just go to atom.io, you'll search for it, and you can find it, and you can just install it from either the app or the command line. And another exciting thing is that, even though we have 1,000 packages, we've had 2 million packages that have been installed. So people are really using packages like to the extreme. If you do the kind of math in your head, like that means a lot of these packages probably have multiple thousands of installs. And so they're actively being used, and they've kind of really, amped up in the last couple months. And if you're interested in more, we do like a weekly or monthly blog post about the coolest new packages. So if you went to blog.atom.io, you could see those. And we also have an Atom feed of all the new packages. If you have an RSS reader, you can get up-to-date information about all the packages every time they get published. Another cool part is that Atom runs on Atom Shell. So everyone that was here for the Node WebKit presentation yesterday, Atom Shell is a very similar product, right? It's an app framework, it's cross-platform, it's Chromium, it's Node, it's got all the DOM APIs, all the window APIs, but it's also got the Node event loop going on at the same time. And if you want to go check that out, that's at Atom Shell is the repo name. And so it's got a very small core where every process has a Node context and a Chromium context kind of glued together. But we also provide a bunch of cross-platform APIs to kind of bridge the gap to all the native integrations you want to make, right? So things like system menus, tray icons, dock interactions. Also window management, so you can have a process that kind of manages these windows, moves them around, minimize, maximize, all that stuff. Also automatic updates, so that's built in to the Atom Shell project, so you can automatically have your app update with a URL that it checks for new releases. And exciting is also crash reporting. So if you actually have if you're using any native Node modules that heaven forbid crash, you'll be able to get reports reported to an endpoint. And so this is kind of just how Atom Shell works, right? You have, in similar Chromium fashion, you have a browser process and a set of render processes. So you can think of the browser process being kind of like the first thing that runs that kind of says, what window should I open? And then I create a window where each render process is hosted in. And the render processes can talk to each other, and then by communicating through the browser process. So when I say Atom package.json on the command line, that tells the browser process, the package.json file has been requested to be opened. Do you have any open windows that can show this file? If so, like bring that window to the front. If not, create a new window. And then those windows can talk to each other if they want to, like if the spec runner wants to know about, like open the file of the failing test, they can go back and forth through this browser process. And one of the big things going forward is that Atom needs more desktop node modules. So if you're all, node, NPM has, 80,000 awesome modules, but very few of them are for developing native desktop apps. And so a quick example of what I mean by that is, if anyone's ever seen this preference pane in Mac OS X, you know there's this section called Show Scroll Bars, and there's 3 options: whether scroll bars are always visible, whether they're never visible, or whether it's controlled by the trackpad. And so when we shipped Atom, like this was the experience we thought we were delivering people, which is this file, because my cursor's not over the scroll bars, I don't see the scroll bars, and that's the, the default behavior on Mac. But if you had changed this setting to always, like you would launch Atom for the first time, and you would see this lovely dark UI with these heinous looking white scroll bars to the top and right. And so we run into this all the time where we need to bridge this gap between the Mac OS X isms and the Windows isms, but we want to do it, by having small modules that encapsulate this behavior, that do it in like a node-centric way. And so we, end up writing a thing where it's like, oh, well, let's, look at the one line of Objective-C we want to write to monitor that setting and emit just a regular, node event when it occurs. And then, in Atom itself, we have a CSS class that represents each of those behaviors, right? Always, or none for the scroll bar settings. And what that allows is like this, really simple way to declaratively say, like when the scroll bar is set to always visible, instead of, these heinous looking default scroll bars in Mac OS X, I want to create some nice, WebKit or Chromium scroll bars using, using this custom background color, height and width, and some borders, which ends up with this, right? So it's a much easier way to kind of build out these nice, small, cohesive desktop node modules that whether it's a Node WebKit app or an Atom Shell app, we can all kind of share these, native integrations without having to all, hack it, and we can, build up this whole library of desktop node modules to make native app development using Node and Chromium way easier to do. And probably the most exciting part is about to come up, and if you've used Atom, you may be really excited by this fact, and this is kind of like the closing note, is that Atom will get faster, and that's really the focus for the entire core team for the next 2, 3, 4 months, is getting Atom to be performant on all 3 platforms, but also MacBook Airs and older MacBooks that may not have some of the luxuries of a newer Retina. And so the current effort being done right now is we're completely rewriting the editor component using the React library, which has been great so far. It really has cleaned up the code, and I highly recommend checking out React. If you haven't already, it's got an amazing documentation, and it's got a really responsive dev team at Facebook, and it's a real joy to use. And we've also moved all the text rendering to the GPU, allowing us to kind of hit the benchmarks that we've set up. So our new goals are under 10 milliseconds per keystroke. So you won't be able to perceive that there's any lag between the time you press the key and the time it appears on screen. And also a big one for us is trying to get to 60 frames per second scrolling, which is actually proving to be very challenging given all the packages that add kind of UI controls to Atom, and also for large files and long lines and soft wrap and all these other kind of nuances. And I am happy to report we've seen some great progress so far. So the top bar is the timeline view for the old editor. So large bars in this graph are way worse because the size of the bar represents the amount of time that got run in response to a JavaScript event. So in these 2 simulations, I'm scrolling the editor and moving the cursor, and you can see how much time is spent, running JavaScript code is one color, and processing styles and then laying out is all those 3 colors. And you'll see in the new editor, it gets way closer to the 60 frames per second time, whereas the old editor at points is getting under 15 frames per second, which is great. So we're getting really close, and every day, and you can track this progress. We have pull requests open every day to improve different facets of scrolling and moving the cursor and copying and pasting large hunks of text, all that stuff. And if you want to enable this, you can open Atom right now. It's off by default currently. We hope to ship this on by default in the next couple weeks. But if you open up the Atom settings and check this box that says Use React Editor, Any editors you open after you check this box will use the new editor architecture, and you'll be able to kind of test it out and hopefully provide us feedback on what machine it's still not working on or what edge cases there might be where you're still seeing perhaps scrolling or typing lag. And that pretty much wraps it up. So I want to say thanks. Also, I noticed a lot of people have GitHub stickers, but I brought a ton with me on the plane. So all the stickers you see in the screenshot I have with me. So if you've wanted a Daft Punk Octocat sticker for a long time and you've never got one, today is your lucky day. Or if you're a huge Star Trek fan, I will put these out at the next coffee break, and please feel free to take as many as you want. And this is the first time we've ever printed Atom stickers, so that's the Atom icon logo. So we have 3 different versions of that. So if you're looking to fill up your laptop even further, there'll be plenty of stickers available. And great, thanks for your time.
Thank you, Kevin. That was awesome. Make sure to reserve 1 sticker for me. If you haven't tried Atom yet, I would say that a good opportunity is today on the afternoon on the workshops. And if you run into any idea or issue, you can check with Kevin. He's going to be around. So our next speaker is coming directly from Portland. She quit a career in healthcare administration to focus on programming and the anthropological study of the hacker species. She is a doer of many things, from Cascadia.js, PDX Node, Node.io, International Notebots Day at PDX, and probably some more. Please welcome Tracy Hinds.
Oh, I gotta fix this. Yep. Get to work on mirroring. Oh, thanks. That's not gonna work. Yeah, I can't, sorry. I don't know whether I was supposed to mirror or not. Yeah.
You want side notes as well, right?
Oh, I'm using Google presentation. Oh, there you go. Oh, yeah, cool. Oh, it's on the right? Up at the corner and then drop down. Sweet. I thought. Oh, there we go. There we go. Perfect. It may just have to show the toolbar. Yeah. Yeah. Sorry.
Não, eu sei qual é o problema. Não, vocês não estão a entender. Isto é o macOS 10.8, o 10.8 tinha um problema de full screen muito mal. E quando eu faço full screen, ele deixa o outro em eligible. Mas eu não posso fazer full screen mode. O que eu tenho que fazer é tipo só maximizar aqui. So if you do the full screen, it's going to close this one.
Right.
Because of the name. So
That's fine to show that way, right?
Yeah, like everyone can see, right?
Yeah, I think so. Yeah, that's totally fine. Okay. Cool. All right, good morning, y'all. This is Merge conflict resolution and management for developers. My name is Tracy Hines. I'm a web engineer at Urban Airship by day. I write Python and JavaScript. A cat herder of organizers in the evenings for PDX Node, which is Portland's local node.js user group. And in my spare time, I'm also curating Cascadia.js 2014. You can find me on GitHub, Twitter, and lurking in the far corners of Freenode on IRC as Hacky-Go-Lucky. First and foremost, I want to say thanks for taking a few minutes and listening, and Lxjs for having me. It's a huge blessing. And also a disclaimer. I am not a licensed professional. My undergraduate education was in psychology, which means that I have 4 years experience trying to diagnose myself with some really bizarre personality disorder. I am trained in crisis counseling, peer mediation, conflict resolution, and I've got experience in both. But this talk is not a substitution for going out and reading or getting training yourself. So way back when Futurama was first debuting, which was 1999, leaders in my high school found themselves at a dead end. There were tons of fights, lots of physical violence going on, and students were pouring into the guidance counselor with some pretty ridiculous arguments, really dumb things. I mean, they're mostly fueled by puberty and raging hormones. So the solution, they decided somehow we were able to get a peer mediation program brought in. Every student in the school was going to be required to take a 10-week training program, and that was 9th grade through graduation. While this sounds pretty extreme, it worked. So you're teaching teenagers to learn how to communicate and communicate effectively about their emotions, which was a pretty powerful thing. The occurrence of fights dropped to 0. And the students started calming each other. We were required to visit and volunteer at the peer mediation classroom once a week for an hour. And as part of that, instead of the guidance counselors or teachers trying to break up these fights, you had a peer, a student of your own age, trying to talk you through exactly what you were dealing with. And when someone's your own age and your own demographic, it's much easier to be able to connect with them. So we haven't been given these tools to facilitate this naturally. It's something that we have to cultivate as adults, or as kids, if we're fortunate enough. So this was a gift given to me by my secondary education. So in this talk, I want to share these skills as they translate in our world, programming. So let's use these skills and make our communities better. We are programmers, but we're also human. And I personally can get pretty fired up myself in debates. I've found this quote poignant. When you hate, you take poison and expect the other person to die. We need to find healthy ways to lift each other up as individuals and as communities. We have amazing talents that we can use for good, but we're getting in our own way by being so venomous to one another. I hope that with these few minutes, I can convince you to take a moment to consider this a worthwhile endeavor. Secondly, I want to share some approaches that we can use as tools to put in our toolboxes to communicate a little more kindly in our programming world. So what is conflict? Conflict gets a bad rap, but that's kind of unfair because conflict isn't inherently bad. Its reality is that it's just a disagreement or a dispute between parties, and they feel threatened about something that's important to them. It can be an interest, a need, a value. Some experts like to make the distinction between disputes, which are short-term disagreements, and conflicts, which are longer-term, more deeply rooted issues. So lesson number 1 is that we are tinkerers, we are engineers, and we are makers. And there's no doubt we love to fix things. We cannot fix it all. There's conflict resolution, and there's conflict management. Both are useful and help address solvable problems or immovable forces. I'll step into both a little further as we dive into the murky waters of communicating online. Social media-based interactions. They're increasingly important to our existence, the way that we're sharing. And as online communities, we've leveraged these platforms to break down physical location differences and communication barriers. The speed at which both positive, neutral, and negative information is relayed has created a beast that is difficult to wrangle. And when addressing these issues relevant to a coder's bread and butter, it can be quite a dilemma. In an age of digital divide and a lack of accountability through internet anonymity, we have such great power that carries along a dangerous amount of responsibility that many don't recognize. Our words are powerful. In order for us to change the prevailing attitude of the technologies we leverage daily, we need to recognize the importance of healthy conflict resolution. Researchers have studied the effects of conflict on closed-sourced software development. In one example, a study surveyed 40 software development teams and concluded that how people work together and mitigate conflict is more important than individual skills and abilities of the team's members in predicting the software development performance. In staying aware and acting deliberately, we can positively share the tiny worlds that we as programmers have created and invite others in. This is the power of these technologies. I have a personal rule of thumb when it comes to using Twitter, and that's battle-tested and also unfortunate that I had to come up with it in the first place. And that's that I am only allowed to use it for knowledge sharing and encouragement. That's it. It's not everyone's cup of tea. I'm not saying you should do that as well. But I tend to sit on my tweets for a couple of minutes before I post them, especially if they are remotely emotion-fueled. It's very tempting to use it as a snappy form of response, but I am not a person capable of wielding that power in a constructive manner. So I'll tell you my first story, and this one is about conference organizing. So how in the world do we convey sarcasm in 140 characters? How about silliness? Or a look of worry that you don't even know that is on your face? How far would I be standing from you if I was trying to make this argument in person? What of the inflection in my voice? Nonverbal communication is 2/3 of all communication. I think many of us have had that aha, that where we realize the person we're reaching out to is having an entirely different conversation than the one I'm speaking to. So I'm going to call this person, my friend, Frustrated and Frank. Frustrated and Frank is upset at the treatment of speakers at conferences and those who submit talks. This hardworking individual loves sharing with the community and is happy to put forth the effort, but has lately been feeling reasonably neglected in what seems to be very common sense areas. Unfortunately, the conference I'm organizing was the straw that broke the camel's back. Since this was the last of a long line of grievances our frustrated friend had experienced, they decided to tweet about it instead of reaching out to one of the organizers, while not mentioning our conference by name. Reading between the lines made it clear to me that this was indeed our conference. As someone who takes pride in my work, I was upset, quite possibly more than I needed to be. And I could have taken the opportunity to jump in to assumptions and be very defensive. But that begs the question, how would that alleviate my concerns that I'm running a conference that awesome people will want to attend, or Frustrated and Frank's hopelessness in submitting talks in the future? The first step I took was to reach out privately. Taking this to a space that allows for honest conversation without third parties that have no real investment in your argument can simplify the debate. The other party is willing to, if the other party is willing to engage this way, you're really fortunate. Don't assume this will stay private. It is the internet. Be kind. This is not an opportunity to be disrespectful because you're out of public view. When all was said and done, the problem was simple. Our organizers are really excited and friendly, and when we travel to conferences, we'll encourage people we see doing cool stuff to submit talks. Frustrated and Frank was one of them. The talk was later declined by our committee, and because this person regularly gives talks, they had scheduled the scheduling can be a challenge for them, and they had soft reserved for ours. So the person was, needless to say, very disappointed. Due to a new process I personally had chosen for our submission and selection process, the declines were delayed in being released. Totally my fault. Still, how did I fix this? There's not too much I can do at this point. I've already let them down. So I owned up to the mistake, to the delay, and I apologized profusely. There was no excuse. And now that's been documented, and in future years, organizers are going to stay on top of how we're informing our Cascadian speakers in a timely manner. As a conference like Lxjs sets the example, we too as Cascadians care insanely about the experience you're getting when you engage with our community. You should not walk away without a smile, and you should not walk away without a hug or a high five. I'll admit, though, I was very lucky that our new friend was so patient and willing to listen to my perspective. That's an exception to the rule. More often, we don't filter the emotion out of our arguments. We are perceiving to be very rational. Online, we end up in arguments about things and stuff. And then we end up in a tangential, but still very important, argument surrounding tone. And then I get turned in circles and forget how to tie my shoes. But in all seriousness, tone shouldn't be a question. If you violate the expectations of civility your counterpart is counting on, listening's going to come to a halt. That isn't constructive. It is unfortunate. We can't connect even to argue if we're so fired up that the words of the argument can't get through the cloud of frustration blocking listening. So another challenge comes into play as well. Most of us are pretty awful at logical reasoning without the added complication of being human and emotions entering the battlefield. So this is an awesome website. This is, I believe, is your logic, is your fallacy logic. Let's see, .com. I'll reference it at the end of the presentation. Sorry, but it's pretty incredible, and it's not all the fallacies, but they are a lot of fun. Unfortunately, we're really good at using these tools in more serious conversations. So let's look at a few. We've got the straw man. You misrepresented someone's argument to make it easier to attack. Putting words in somebody's mouth. Ad hominem. You attack your opponent's character or personal traits in an attempt to undermine their argument. Happens all the time. Personal favorite, the bandwagon. You appealed to popularity or the fact that many people do something as an attempted form of validation. Everyone's doing it. All right, so this time, I'm going to have you guys stand up. It's a test to see if you're paying attention. All right, lots of noise. All right, yeah. You're welcome to stretch if you want. So if I started making broad, gaping statements regarding Angular or Ember right now, would I make your blood pressure boil a little bit, raise up a little bit? How about my preference for callbacks over promises? But bear with me, these are all hypotheticals. I'm not making opinions on any. I don't really use either. OK, so if in JavaScript you use unnecessary semicolons at the end of your code lines, sit down. Unnecessary. If you don't use a comma first syntax, sit down. Yeah, all right. So, you rare, beautiful birds. This is my personal preference. You all still standing have obviously superior aesthetic in your code. So, thank you. You can take a seat. But really, it's all horrible logic. So in reality, we need to focus on people in our debate, or not focus on people in our debates, and stick to the plan, which is healthy conflict. Remove the pointed you in the fight. So the next story I'm going to tell is about some work that I was doing prior. And that was in crisis counseling training. So I decided a couple years back, after having a number of my friends go through some really hard times, that I needed to find more perspective and help learn more empathy for people that I couldn't really find an understanding for. So I started volunteering at a crisis hotline that was approximately 6 months of training, and that was in-person role-playing regarding taking phone calls for somebody who might be suicidal. We also had to take moderated phone calls of people who were actually calling in, and it could be at 2 o'clock in the morning, and you needed to keep them on the phone. But the power in the training itself was in sharing how you don't matter. Your perspective doesn't matter in these situations, because if somebody's calling into this place, there's no way that you can empathize because they are an individual. You may have gone through a similar circumstance, but it's a dangerous place to go if you try and share that you understand, because you can't mind read. But in terms of conflict and how you can speak to other people, the takeaway I got from this was that I don't understand. I don't understand other people, no matter how much I like to think I do. And pausing when I have that opportunity, stepping back and allowing other people to speak will end up enlightening me when it comes to something that I may not have agreed with. So this is what I carry through my experiences now. The things I have to ask questions for myself. When I come to the table for a discussion, I need to be prepared by having explored my personal agenda and preconceptions. I will project a lot of things on you. What personal needs am I possibly trying to deal with in this argument? What am I expecting or hoping to accomplish by holding this battle, personally and professionally? What selfish agenda do I need to admit to myself to avoid it impacting in the case I'm making? What is it going to take for me to do a better job of keeping my ego in check? Ultimately, we are all consumers of each other's work. Does this make us backseat drivers, armchair quarterbacks? At some point, I really am very likely to use it. I'm pretty invested in what you're doing. If there's a possibility, I'll be using it in the future. Some are so exercised in sharing their opinions that this will happen regardless of whether they could see using it. Successful conflict resolution depends on regulating stress, your emotional awareness, and nonverbal communication. And especially online, that can include actions we take on projects. So first and foremost, we want to understand the conflict. Whether it's a PR or a tweet, this can impact your livelihood, your reputation, or your sanity. Number two, we want to communicate with the opposition. Reach out. Posting an issue and waiting isn't always ideal. Be kind, be proactive, but don't be a nuisance. Engage. Brainstorm your possible resolutions. Offering up opinions on how wrong something is can be valuable, but it isn't very constructive. Bringing one or more solutions to the table is, and it's possible your soon-to-be friend didn't think of what you're offering. Next, you're going to be choosing the best resolution, ideally, along with your new friend. And you're going to have to cope with any stressful situations and pressure tactics that arise. And of course, you're going to have to rinse and repeat. It happens. New people are going to come into the mix, into the arguments, very likely because you are not isolated, and people will often want more perspective. So merge resolution. The negative effects of unresolved online hostility and attacks and reputational harm are daunting. On the business side, conflict can include lower employee morale, reduction in work quality, lower productivity, loss of employee loyalty, the list goes on. Personally, ongoing or unresolved conflict can result in stress, anxiety, depression, diminished work productivity, social isolation. It's nasty business. So the answer for me comes to focus on me. I can't change you. I can meet an expectation that I'm walking up to the table in a calm place, and I'll collect myself before I'm presenting my argument. If I set a precedent of goodwill and logical arguing, you'll know what to expect from me in the future. You're far less likely to make an assumption of malicious intent or triggering if you know where I come from. Every choice you make in your conversations, you're traversing a fork in the road. Everyone is. It can end up being a perfect storm of awful, or a road to resolution. All right, and this is just the list of resources that I used. We've got the website for the fallacy, the logical fallacy poster. And thank you.
Thank you, Tracy. Thank you. Get on stage. Thank you. So our next speaker is a hacker at heart, is a truly black magic wizard that has brought us the state of out of this world projects such as PeerCDN and WebTorrent. So please welcome Feroz.
Just need a minute to set up. Cool. Sorry, you're getting a preview of my talk right now. All right. I think we're good. All right, hey everyone. So I'm Feroz, and I'm here to talk to you about the peer-to-peer web. And when I say peer-to-peer web, I'm talking about WebRTC. So WebRTC is awesome. It's a way for two browsers to talk directly to each other, completely peer-to-peer. And so traditionally, the way a lot of web services are built is a model like this, where you have a central server and you have browsers talking to each other, but through the central server. So the server can see everything that the peers are doing. And this is like how Facebook chat works and how most of the web services that we use every day work. What we want to do with WebRTC, and what WebRTC enables us to do, is to build services like this. So it's better for privacy. It's better for just if you want to save bandwidth, it's architecturally a lot nicer, and it's actually going to allow us to start to decentralize the web again, which makes me really excited. So on hearing about this, you might have some questions like, how is this possible, right? I mean, what about security? Having browsers open up connections to each other sounds like it could be dangerous. What about the same origin policy? Does that even make sense anymore with something like this? What about asking the user for permission before you open up a connection like this? What about users behind firewalls or NATs? How is the connection going to work? And isn't this crazy? Isn't this just madness? And as it turns out, WebRTC actually has a solution to all of these problems and more. So peer-to-peer is actually possible in the browser, and it's not crazy. It's just WebRTC. It's the world of black magic. So let's talk a little bit more about it. So it's a web standard. It's a W3C and IETF standard, and it exposes a simple JavaScript API to you. It supports voice and video with amazing video quality. And this is the part that really excites me. It also supports arbitrary data, both reliable and unreliable. So you can build whatever kind of application your imagination allows you to build. And like I said, it's peer-to-peer. So why is this exciting? First of all, if you ask that question, you should probably just leave, because it's obviously exciting, right? It fundamentally changes the web, and it makes it more powerful. As the WebRTC lead at Google said, WebRTC is really just, it's a project to bring real-time communication to the open web platform. So really, it's about making the web more powerful, adding new features to it. So A few more things about it. There's no installation required, of course, because this is a web standard. It's built into the browser. So it currently works today in Chrome, Firefox, and Opera, which is about 50 to 60% of the market, depending on your particular website. And what about Microsoft, right? What about IE, and what about Safari? Turns out I'm pretty optimistic about those browsers and their plans to support WebRTC, because Microsoft has a new site now where they talk about their plans for supporting web platform features. And this is what they have up there for WebRTC. So they say, we don't like the current API. We're not currently planning to support that. But we want to support this other thing, which is the object API, which will let you do the same thing, but it'll just be a different API. So it's not ideal, but it will allow us to abstract those differences away, and we'll be able to have different browsers talking to each other. And what about Apple? So Apple's been very quiet, but there's this post on a mailing list, on the WebKit mailing list, where they're beginning to merge code from Blink, which is Google's fork of WebRTC, Google's fork of WebKit, and they're starting to merge some of those changes back into WebKit, which is really exciting. So I think they're planning to support it at some point. And yeah, so like I said, we have three browsers that support it today. If you have an Android phone, Chrome and Firefox on Android also support it. So it works across devices. And I want to show you guys some examples now of cool things people have already built with this today. So let's take a look, just so you can get an idea of what is possible. So let's get this over here. OK. So this is a really cool service. How many of you have heard of Talkie before? Oh, wow, that's way more than I expected. Cool. So anyway, this is a simple video chat service where you can really quickly get up and do a chat with anyone you want. So you type in a name for this conversation, and anyone who goes to this URL here will be in a video chat with me. So why doesn't someone just type that in really quick? Talkie.io/test. And let's see that it works. Nice. Hey there. Cool. So yeah, and you can chat, and it's no plugins required, no installation required, multi-party chat. It's pretty freaking cool. No account is necessary. So this is probably going to crash my computer. Anyway, I'm going to close this now. So there's other uses as well besides video and audio. So this is a really cool example. It's called ShareFest, and it's a way to send files from one computer to another really seamlessly. So all I do if I want to use it is I drag a file from my computer. Let's drag this file here, drop it on this page, and is the internet going to cooperate with me? Let's give it another shot. There we go. So cool. So it gives me this little URL here, sharefest.me/CA9813BB. If one of you guys wants to type that in, you'll be able to download the file that I just dropped on my browser. So again, no installation was necessary. You didn't need to install Dropbox. You just visit this URL, and then the server will coordinate that our computers will connect to each other, and then my computer will actually send the file directly to whoever visits this URL. And it's completely peer-to-peer. The server never sees the content of the file, and it's streaming, which means that I can start to send you the beginning of the file, and you start to receive the bits right away. And so it's, in my opinion, better than Dropbox, because you don't have to wait for the entire file to upload to the server before people can start to download it. So it's really great for getting files quickly to people. And if you're on a NAT, if you're on a local network, then the file never leaves the network. So it's super fast. It will go over the local network. I want to go a little more quickly through these other examples. So this is Pure CDN. This is a company I started. And we used WebRTC to enable enable browser cache sharing. So the idea was, if you visit a website and you download a bunch of resources, images, videos, and things, for the duration of the time that you're on that page, you should be seeding that content to future visitors. So it reduces the load on the server. And that was kind of a cool idea. We were able to reduce people's bandwidth. There's Together.js, which is a way to drop in video chat into your site. There's Chromecast is using WebRTC. They're using it for the tab casting feature. So when you want to send the content of your browser tab to your TV, that actually uses WebRTC. Amazon is using it in Mayday, which is a way to have one tap button on your Kindle and talk to a support agent. So you just tap a button, you wait like 5 seconds, and then you're on the phone, and you see a support agent on your Kindle, and you can talk to them and figure out whatever problem you're having. And lastly, Snapchat acquired a WebRTC company for their video feature. So WebRTC is everywhere. It's pretty cool. But there's this quote from Chris Cranky, who's kind of like a WebRTC analyst dude, really cool guy. And he said he popped into a recent HTML development conference, and he was surprised at a lack of general knowledge by the geeks at large about WebRTC. So these examples I've shown you are pretty cool, but there aren't many more besides these. So what I think WebRTC needs is like more recognition by web developers and more understanding so that we have more apps besides these. WebRTC has been out for 2 or 3 years in production browsers, and there aren't many more apps besides these ones that you've seen here. So I'm hoping that after my talk today, you'll feel more comfortable going out and building some WebRTC apps yourself. So what we need is more mad science. That's what web developers bring, is mad science. So I want to show a couple more things that I think are mad scientific. There's Pure Server, which is a server in a browser. You can basically, it's an IDE, you can build a whole site with a backend and stuff, and then you push host, and then you get a URL, and it's completely served from your browser, which is kind of neat. And then there's WebTorrent, which is my project to build a BitTorrent client in the browser, which I'll mention a little bit more about later. Which I'll mention a little bit more about right now. So WebTorrent is a BitTorrent client that requires no installation. So like I said, no plugin, no extension. And the goal is to have it interoperate with the regular BitTorrent network. So I want it to be the kind of thing where it's in the browser, it talks to existing clients, and it streams videos to you. And so it'll be really easy to share links, and it's all on the web. And this sounds crazy because you can't just open up random sockets, UDP and TCP, to talk to BitTorrent clients that are out there. So we're going to have to be a little clever about how we accomplish this. So just really roughly, this is how the plan is to make it work. There are BitTorrent clients out there, right? They talk to each other. That's represented by these orange links. They're speaking the BitTorrent protocol. And then we're going to build some hybrid clients. So these clients are going to speak the BitTorrent protocol, obviously. They're going to be able to talk to the existing network. But there's going to be these new types of clients, which are web-only. They only speak WebRTC. And they're going to speak to the hybrid clients. And but the hybrid clients will speak both, right? So if you're a web client and you want to download something, and you have like the info hash of the torrent, you can do it as long as another web client has it, or as long as a hybrid client has it. If a normal BitTorrent client has the file you want, and that's it, then you're unfortunately not going to be able to download it, because this is not possible. You can't, WebRTC can't, it's not the same as TCP UDP. It's a fundamentally different thing. So these middle nodes are really going to be really important. And so the plan is to first to build a native client. That's the hybrid one that was in the middle. And it will be a native client that you can install. And then later to build the web client. And then to add WebRTC, obviously the web client uses WebRTC, but to add WebRTC to the native client as well, so it can talk to the web ones. So I started on step 1. I wanted to build a torrent client. And I started writing all these modules to accomplish that. And I kind of got sidetracked and wrote a ton of them, and basically built a whole BitTorrent client in Node. And it was kind of cool. I figured I should understand how this works before I attempt to do it using WebRTC. All these modules are small. They're little pieces of functionality that you need to implement a client. And what's cool is they're actually used by some other projects. There's this really cool project I encourage you to check out. It's called PureFlix. And it allows you to stream torrents to VLC. So you just type in the URL, the magnet URL or the link to the torrent, and then you wait like 5 seconds, and then VLC opens and it starts to play, and it's really cool. And you can seek, and everything just works. And then there's even a crazier project, which is called Torrent Mount by the same guy, and it actually allows you to mount an entire torrent as a file system on your computer. And when you open up any of the files, it will live fetch it from the network in order to show it to you. So it's crazy cool. The guy's GitHub page is github.com/Macintosh. It's totally worth checking out. But anyway, back to WebTorrent. So most of these modules that I showed you are going to be browserifiable. So they're going to be able to run in the browser, and that work will be able to be reused for WebTorrent, which is pretty cool. And the ultimate goal is to get to something approaching this, where you can just include it in the page as a script tag. And then you can call a function that says, I have this PDF, here's the hash of it, please show it to me in this div called viewer, and then it will just fetch it from the network and show it to you. Similarly, for video, you could just do something like this. You could say, here's the movie, and once you get the stream, just put it as the source of the video, and we're good. So that's webtorrent.io. But what I want to spend the rest of my talk talking to you about is, back to Chris Cranky's quote, I want you guys to leave feeling like you feel empowered about WebRTC and you can understand it and do stuff with it. So I thought it would be cool to try and build a clone of Omegle right now. So how many of you have heard of this site? It's like chat roulette. How many of you have heard of that? OK. Wow, more of you have heard of Talkie than have heard of chat roulette. That's surprising. Anyway, so it's basically a site where you go on and you can talk to random strangers. And it uses Flash. And I thought we could build the same thing, but using WebRTC. So first thing is there's this API we have to use called getUserMedia. And it's really simple. All we do is, let's see, can we show my editor? Yep, cool. OK, so all we're going to do is we're going to call this API, getUserMedia. It's browser prefixed, unfortunately, so that's why I'm saying WebKit getUserMedia. And it has a success and a fail callback, and also some constraints. So for the constraints, we're just going to say, give us video. We're not interested in audio for this demo. And for the success callback, we're going to get the stream, and we're going to create a video tag. And then we take the stream and we turn it into a blob URL using this, this call right here. And then we set it as the source of the video and play the video, and then add the video tag to the DOM. And if we fail, we just print out the error. And so we can see that in action. It's just right here, so I'll refresh. So you see the browser is asking to use my camera. I'll click allow. And and it works. Cool. Nice. So really easy, really simple. But the thing is, this only works in WebKit. So let's fix that. Let's make an abstraction layer to make this a little bit nicer to use and clean up some of the rough edges. So one thing we need to do is handle all the possible names of this API. So we do that with this big chained OR statement. And we're going to export a single function. So I'm writing this in Node style because I'm going to browserify it. So I'm going to export a function called getUserMedia, and then it's just going to call getUserMedia. And it'll pass in the constraints that the user passes in. And what we're going to do is we're actually going to transform the API to be Node style, with error first, callback style, just because I like that. So we're going to have a success and a fail function. If we're successful, we just call the callback with null first. And if we fail, we just call the callback with an error first. Really simple. And let's make this a little bit nicer. So let's allow the user to omit the constraints if they want. If they omit the constraints, we just set that to video true and audio true for them. And then lastly, there's one thing we need to do to fix this up in Firefox, which is Firefox, when it calls fail, sometimes error is, well, actually, always error is actually a string instead of an error object, which is a little bit annoying. So what we're going to do is we say if error equals this particular string, which is that the user denied us permission, then we're going to create an actual error object and emit that. And we do that with this module called custom error, which allows us to just create a new error object that inherits from error. And then we do that also for constraint not satisfied, which is another type of error that it can emit. And that's about it. The last thing we do is we're just going to create a little helper to show the stream in a video tag. So you give it the video tag, you give it the stream, and then it just does this simple creation of the URL, setting it as the source, and calling play. Really simple. So cool. That's how you get access to the user's camera. But after you have that, how do you actually find the peer you want to talk to? So in WebRTC, they leave this up to you. It's up to the user to figure out. It's up to the application writer to figure out how peers are going to discover each other. So what we're going to do is we're going to have a central server that just kind of coordinates which peers are online. And when one peer connects, it says, please introduce me to the next peer that connects. And then whoever connects next will get introduced, and those two people will be in a video chat. And if a third person comes during that time, what we're going to do is we're just going to have them wait until a fourth person comes. So we're only going to support two-way chat for this Omegle clone. And so let's see how that would work. So that process is called signaling. And it's important. So remember, we're doing peer-to-peer here. So peers are going to talk directly to each other. But first, the peers need to learn about each other. They need to learn what the other person's IP address is, what their port is. And so we need to do signaling. And so signaling involves a central server. And it kind of has a flow like this. So first, we get user media. And that has a callback that gives us the stream, the video stream. After we've done that, we create this. We initialize this constructor called RTC peer connection. And this is what's going to allow us to actually this tells the browser that we want to actually do a peer-to-peer connection. So it creates this object, and then we call add stream on that object, saying that and passing it the stream. So we say this is the video that we want to send to the other side. So once we do that, it's going to emit this event that says, oh, negotiation is needed. So it means that the add stream didn't really do anything yet, and now it's our job to make sure that we send the necessary data to the other side so that they'll actually get the video. So we handle this event by calling create offer. So that returns this thing called an offer. And you can think of it as just an opaque blob. It's actually what it contains inside is the listing of all the codecs that your browser supports, all the video codecs. It includes an encryption key, a shared secret that's going to be used to encrypt your video, and it includes potentially a bunch of other things. And what you do is you call set local description, which says OK, so here's the offer that I want to use. And the reason why that's necessary is it gives you the opportunity to change the offer if you want. So let's say you don't want to use a particular codec. You can delete that line from the blob, and then that codec won't be used. But in general, you don't need to do that. You just blindly call it, and you're good. So now we have a server, and we send the offer to the server, and the server sends the offer over to the peer we want to talk to. And that peer, when they receive the offer, they know, oh, someone wants to talk to me. And then they call the same constructor on their side, which creates the object. And then they call set remote description. So they have this offer, and they say, that's the offer from the other side. And then they can call get user media, get their video stream, and do all that kind of setup. They call add stream. And then they say create answer. So this answer it's kind of like a challenge response thing. So the answer is based on the offer. So they get an answer, and they send that. They set that as their local description, and then they send that to the other side. And then the other side sets that as their remote description. So it's parallel. Next, so now the peers know about each other. They know all the constraints. They're ready to connect. The only thing they don't know is what is the IP address of the other peer, and what is the port that I need to connect to. And so the way those are gathered is that the browser emits these events called ICE candidates. And so this event gets emitted, and the candidate object is literally just like a string that says, this is my IP and this is my port. And there can be multiple of these emitted if you have multiple interfaces on your machine, like Wi-Fi, Ethernet, a local IP, a public IP. And your job as the application developer is to just send those to the other side, just like you did with the offer and the answer. So you send the candidate over. The other side just says, oh, I got a candidate. OK, I'll add it. And then if any candidates get emitted on the other side, you just send that over to the other side, and then they add it as well. Really simple. And then finally, after all this, at some point, this add stream event will get emitted, and you'll have a stream which you can set as the source of video tag, and you'll see the video from the other side, which is awesome. And similarly, the same event will get emitted on the other side. So there's a lot of steps, but once you've done this, you have peer-to-peer video, which is really cool. Now, if you wanted to do a data channel, so you want to be able to send text data and binary data across, you would use this other method called create data channel, which returns a channel. And then the thing about data channels is they're inherently two-way. So do you remember in the video example, we called add stream on both sides? The reason why is because when you create a video stream, all you can do is send it to the other side, right? But with a data channel, they decided to make it two-way. So only one side needs to create a data channel, and then both of them can use that channel to talk to each other. So in this example, the left side is going to create the data channel. The right side is going to get an event that says, oh, the other guy created a channel. And now they both have a channel object, and they can use the channel object to send messages to each other. And they'll arrive on the other side as a message event. Cool. So I will show a little bit of how that would work. So we have this page here, this HTML page that we're going to use as our structure. It's really simple. And actually, before we go too much further, I want to show one more thing. So the thing is, this whole interface is kind of complicated. It's like there's too many steps, right? And like we don't want to deal with this every time we want to handle connections. So what we should do is create a class that kind of hides all that complexity away and just makes it easier. So I think it would be much nicer if we could do something like this, where we could just say new peer, and then you could say one side says that they're the initiator, and the other side would say they're not the initiator, and then you pass in the video stream in the constructor. And then here's what I'm imagining the flow would be like. So when you create a peer object, it will handle creating the data channel, adding the stream, all that stuff for you. And all it will do is emit this one event, signal, which says, I have some data, please send it to the other side. You don't even have to think about what the data is. We know it's an offer, but the application doesn't need to know that. So whenever it gets a signal event, it just sends it across through the server to the other side. And all the other side has to know is, oh, I got some signaling data. I'm going to call the signal method with it. Okay? And then the other side does the same thing. It'll emit these signal events, and those will go across. And the other side, all it has to know is, oh, I got some signaling data, and then shove it into the peer object. So when candidates go through, it's the same thing. It's just a signal event. And same thing on the other side. They're just signal events. And then at some point, it will emit the stream to you, which is the video from the other side. And then it will say ready. And ready just means you can use the data channel now. So you can call send, and the message will show up on the other side. So I think this is a little bit simpler because your application only needs to handle the signal event and needs to call the signal method. You don't need to worry about all that other stuff. So we can write a class like that. Oops. OK. So that class is, where is it? Here we go. OK, cool. So I'm going to go through this kind of quickly. It's basically what you just saw in that diagram. Basically, what we're doing is we're doing these shims here to abstract away the browser differences. We're requiring some things. We're setting some config options on the peer connection object. This is just a stun server. And then we set up some handlers. So this event fires on the peer connection whenever the state of it changes. So once it goes into either the connected or completed state, that's just what they call it, we're going to emit a ready event. And whenever the connection state changes into the disconnected state, we're going to emit a close event. Then we're going to listen to the ICE candidate event, and that's the thing that just emits those candidates, those IP address and port pairs. And anytime one of those gets emitted, we just emit signal. We do some video setup and some data setup. And we create offer, set local description, and set up a data channel handler. Yeah, I mean, so it's exactly what I showed in the slides. We call create data channel up here, and then the event will get emitted down here. Anyway, I'll post the code online for this. It's a little bit more than I actually thought I would be able to show. So let's skip right into the last part. So right here, we have, this is actually the client-side code. So it's surprisingly simple because of this peer class that we just wrote. So all we're going to do is set up some variables for DOM nodes. And then we're going to have some little helper functions for disabling and enabling parts of the UI, like the send button and stuff. And we're going to have a little method for displaying chat messages on the screen whenever one comes in from the other side. And then we're going to create one of these. We're going to create a WebSocket, which is going to talk to the server, which is going to help us out to find peers. So once the socket's ready, we're going to get the user's media. And then we're going to show the video into a local video tag in the browser. Then we call next, which is the way we get new peers. So all we do to get a new peer is we send a message to the server with the type of peer. And then that tells the server we're looking to be introduced to another peer. So when another peer arrives, it will send us a peer message with all of the with their offer and their answer. And so this is what a peer message looks like. So this is the way we handle it. We create one of those peer objects. We say whether we're the initiator or not. And then the peer. So now this is basically the abstraction that we created over the peer connection. So it's going to emit these different events. So when the peer tells us they're ready, we say that by just showing a little message. When the peer sends us signaling data, when the peer emits signaling data, we just send that to the other side. When the peer emits a stream, we just show the stream. When the peer sends us a chat, we just show the chat. And that's basically it. And the last thing we need to do is just, when we receive signaling data, we just need to pass it into the peer object. And the very last thing is we just have a send method to send chats to the other side using the send method on the peer object. Really simple. So tying all that together, what we end up with is this demo right here, which will either be really awesome or will be a horrible fail depending on if the network cooperates. So everyone go to webtorrent.io/8080. And this is what we just built. So I'm going to be matched with a random, oh my god, there's a lot of you. I've not tested it with this many people. OK, cool. Yay, it worked. So I got a random person. Who is that? Raise your hand. Hey. All right, so we can talk to each other. Wow, that's 45. That's insane. Cool, so we're talking to each other. Nice. Now I'm going to click the next button, and I should be paired with someone else. Same guy, OK. Hey, what's going on? Let's try a different person. So everyone right now is getting paired with different people. And, huh? What? Oh, really? OK. Well, it's not as random as I'd like, but anyway, so that's the demo. Cool. So anyway, if you want to check out the code for this, the complete code is online at GitHub at this URL. And if you want to check out the peer class that we wrote together, that's online at this URL. It's its own NPM module. And go forth and hack. Build great things with WebRTC, please. And check out WebTorrent if you're interested in that project. Please share your feedback and give it a shot. And wish you guys all luck. Happy hacking. Thanks.
Thank you, Burles. That was awesome. Thank you for coming. So I was thinking, can we use your app for the ruffles now?
Oh, sure, yeah. Is there URL? Instead of
We can do some with the first thing. Can we do that?
Sure, we can give it a shot.
Okay, we're ready. So the next speaker has, this is unofficial, but he has a PhD in, it's actually, okay, an academic PhD in Internet of Things. He's the author of several open source libraries related to Internet of Things, like MQTT.js, Mosca, Ponte, and LevelGraph. And he's also an avid Level Up contributor. So please welcome Matteo Collina.
Thank you, everyone. Thank you, the Lxjs organizers, to letting me here speaking about hardware and the Internet of Things. So let's first start with the first check. So, do you everybody see the camera on the left? Hope so. Maybe we can even go full screen. You should read it, right? Are you reading it? Are you not reading it? OK, so. Perfect. So this is OK. So let's keep on. What we are going to talk today? Well, today I'm showing you how to build Internet of Things apps using this protocol called MQTT. Well, why does this matter? You see this is a tiny LCD here. It's connected to an Arduino Uno. It creates its own Wi-Fi network, so please be gentle. If you see a Wi-Fi network called Arduino Uno, please do not connect. Otherwise, my demo won't work. So please, be gentle. So this is my LCD, and I have this little form on my HTML5 slides. So I can start typing hello, OK, which is very nice, guys. And I can turn, and you can see it on the. OK, let's do this again. So. Yes. Come on, demo effect. OK. So you can see it on the display. So this guy is connected to my computer. And this is open a Wi-Fi network. And I'm using this protocol called MQTT to control it. I also have one more thing. Well, what's MQTT? MQTT is a publish subscribe protocol, which means, well, publish subscribe means that you can connect multiple devices and exchange it and send data to all of them. MQTT has multiple quality of service, which means that you can get, I don't know, at least one semantic or exactly one semantics, depending on the requirements of your application. It's little overhead, which means actually that it can consume at minimum like 2 bytes per hour of payload, which is very little. And you can run it on 2G networks in a very inexpensive way. It has offline messaging, which means that all the offline part that it's already handled, it's already done for you. You should not do anything to support offline. When you connect back, you will receive all the messages that you have lost. It also has retained messages, which is a feature for, it's like a key value store in there. Well, how does this matter to robots? We'll see in a moment. Well, MQTT is publish subscribe, so in order to receive some data, you need to listen or subscribe for stuff beforehand. So, why we want to build robots? First of all, to change the world and sense the real world, right? Well, we can control our LCD from our tiny little HTML5 slides. HTML5 slides are extremely cool. And I can use them to actually execute some code live. So, well, let's start executing this one. I've showed you from the form in my HTML5 slide. Let me execute this code. So if it works. OK, Lxjs. Thank you. Hello, everybody. Hey. OK, so that's back. I love MQTT. OK, so. I also have an infrared temperature sensor. And I have the ambient temperature and the object temperature. So does anybody knows where I'm wearing this sensor? OK, so this is my sensor. This is a tiny, this guy is a tiny Bluetooth low energy device called sensor tag. It comes with its own NPM module. So you can control it from Node, OK? It gives you data live, and I'm just streaming this data from MQTT to my slides. Yes, let me show this to you. OK, so you can see it, right? It's a little bit tiny, and, well, whatever. So, well, we can do crazy stuff. For example, start printing our temperature to our LCD and building a thermostat, right? So we have this tiny little code that creates an MQTT client, subscribe to the topic I'm using to publish the data from this sensor tag. It emits us some data every second. And then when we have it, we just print it to publish it to our Yun topic. The Yun is connected to the prints everything on the that is published on the Yun with a Yun prefix. Okay, and then after 3 seconds, we just close everything. So let's run this, and we are seeing the temperature, right? It's the same temperature we see in the previous slides, and we are just connecting it, live connecting it to our order. So, OK. Some stuff starts going wrong, OK. You know, dim effect. Things stopped working. So when things stop work, you know this little thing? Do you like segmentation fault? This is, you know, when you have binary add-ons and you are in a talk at an international conference, things start segmenting. So let's hope this works again. OK, so we have it back together. So I'm using MQTT also from the data I'm publishing from this device to control the slides. So actually, the HTML5 slide toolkit that I'm using called Bespoke.js. If you don't use Bespoke.js, you should use Bespoke.js. It's amazing. And actually, and so I'm publishing some stuff from here. And you can see I'm publishing on a topic deck. And this little sharp that you see is like a wildcard. It's a wildcard. So everything that's directly to the deck, which is my slide deck, I will publish it to the Yun. OK? So we can try a little bit playing with this guy. OK? You can see Yun deck next and can come back and come forward, whatever. Then it goes back to I love MQTT. OK? So I'm controlling the slides through this guy. How I'm doing this, all of this? Well, first, this is connected to via Bluetooth Low Energy through this node program that just got segmentation fault. So you have seen it, me restarting that program that is doing this stuff. It received the events from the buttons, from these 2 buttons. You can see it over here. We have a button on the right and a button on the left that I can click. So I can click the button and turn and move stuff. OK, the web application is connected to my broker using WebSocket. MQTT is a binary protocol. But since I don't know what version, we can have binary data over WebSocket. It's not for Internet Explorer, guys. Only Internet Explorer 11, but I have not tested it. I'm sorry, Internet Explorer. You're out of the Internet of Things, maybe. Well, and then this data comes to my slide deck, and it triggers a sliding API. So, OK. So I have some more hardware over here, right? So what I'm going to do first, this is a nice push button, OK? I think you can buy it from Adafruit, whatever. This is the button, OK? I've made some very bad soldering, as you can see, to get this thing. It has 3 connections. This one is the power. And this one it's connected to the power when the button is pressed. OK? So this is my bad soldering. I'm not really good at soldering, guys. So what can we do? Well, first of all, we need an Arduino. I have an Arduino here. It's an old one. It's an old model, I think. OK? Whatever. Very old friend. Done a lot of stuff with him. So we just wire our thing here and over here. And then we turn the camera. So you can see what I'm doing, right, guys? OK, so we get our button, and this is the power. So we connect it to the power over in our breadboard. And we need some more thing to get the power there. So whatever. OK. You know when you start seeing, OK, I'm not doing any live coding live. OK, I'm doing hardware. This is the first rule of doing a presentation, never do live coding. I'm hardware, so whatever. So we need 5 volts, and we need the ground, OK? And, yep. OK, so then we have this thing, which is our, well, this is it, OK, which is our data sensing thing. So I'm using a little resistance over here as a pull-down resistance, which means to have it to 0 when it's not connected, because otherwise it's floating. If you are into hardware stuff, this means something. If you're not into hardware, forget about what I said and put a resistance. OK, this is a nice red LED. So we are just touching this here, and, well, whatever. And over here. And then we wire this to mass. So, oh, come on, man. OK, yeah, I got it wrong. Over here. OK, so we have a little light. We can blink a light. So this works. So let's wire the other ones. It's, well, simpler. Over here. Whoop. OK, so we have a red button, and we have a blue button. And we have a yellow button. It's not blue, whatever. It's the cable I'm using. We need a little resistance over here connecting. Here we go. And a tiny LED, too, so we can just keep seeing if everything works fine. LEDs are very extremely cool stuff to use to see if you to debug your other projects. So, and we wire it to the ground too. OK? So here we go. OK? So we can have a red and, OK. So, well, let's move to some more nice stuff, some coding. So can you all see the code? Yes? Well, OK. How many of you have done the, how many of you know Johnny 5? All of you guys. OK, so you are familiar with Johnny 5. So we can create a button, and OK, and connect it to the 7 thing. And we need it here. OK, so and when this is pressed, OK, we can print something. OK, so OK, so let's start this thing. Oh, yes, it should be connected. OK, so let's try it. We need to connect it to 7. Over here. OK, so it might work. OK, so we wired our button. Let's wire all the other ones, which we need for our little demo in a moment. So let's wire 8 to over here and over here. OK, and oh yeah. But you're not seeing what I'm doing, so it's very nice. And well, OK, so we have write 8, and we need to change our code to handle this stuff. So let's make a nice little function to create a button. OK, we take a number. And we have this thing here, and whatever. Here we go. OK, so here we are. And we have 7, so we are just saying num down. OK, so we have 7, and OK, if you don't like this, I'm sorry, guys. And here we go. So let's try starting this stuff. Oh, fun. Yes, thank you very much. You are following what I'm doing, so maybe the talk is going well. OK, so here we are. OK, so we have this kind of 2 things. This is not working. And this is not working anymore. What's happening? Here we go. OK, let's go for the nice and simple way. This is the nice and simple way. Yes? OK. So 5 minutes. OK, so I'm going to be fast. OK, so we have 2 of them. So let's wire the 3rd one super fast. Otherwise, they are killing me, and because I'm going over time. And we all eat lunch later. So whatever, over here. So here we go. Let's wire this thing. OK, so we have the 3rd LED. Over here, we need the resistance. Otherwise, this thing won't work. Or you will start to see crazy numbers, which is even better. OK, so, and then we need to send this stuff to the 9 button. OK. So, fun stuff happening. You know, hardware is hard. And I'm sorry, Pedro, David, I'm going over time. And here we go. OK, so here we are. So we can wire it the 8 button. It should be easier right now, because we have all this in place. So we are 9. OK, so here we go. Node button. Let's start seeing if it works. So, OK, this Arduino, I said it's old Arduino. OK, so let's start this Arduino again. OK, so 7 down, 8 down, 9 down. OK, so we have wired our big buttons. What can we do with this stuff? So we are using MQTT. So let's do some MQTT live. So we require just our MQTT library. OK. And we create a client. Sorry for the C name, but it renders nice on the screen. And we create a client. OK? So with this client, I'm just having to say a color for each of our buttons. So we have a color. So we just print the color here. OK, just to. And then we publish some stuff. So C publish votes. And we publish the color. OK? So maybe we are building a voting machine. Don't know. So we just publish our data. And these, we have the 9 button. The 3 buttons. We pass the color. So 7 is red. 8 is yellow. And 9 is green. OK, so yes. So here we go. Do you think I have to restart this thing? No. OK, working. So we are wiring this stuff here. OK? We may wire directly to our LCD display, but since I am over time, I am just showing you some more stuff. OK, so you see this little thing? Chrome crashed. OK, I'm sorry, guys. I need to restart Google Chrome. Yes, thank you. OK, so when you think, OK. So, OK. So we have votes. We can have our live vote machine. And, well, we can move our camera over here. So you can see again our Yun. And we can receive the votes. And we just increase the counts. OK? So we can keep track on if you like my talk or not. So let's start doing this. OK, so here we are. So let's push this. What's happening, guys? Demo effect, this stuff was working. OK, so how we debug this? Whatever. We can just say, OK, so you can see some stuff going on. It's not publishing stuff on MQTT. Have I saved this? Oh, yes, OK, it should be. So votes. OK, so whatever. Why? OK, I have to fix this, guys. Oh, yes, definitely. Yes, thank you, Pedro. Yes, it should be inside the callback. Otherwise, whatever, it's not going to work. Yes, so let's see if it works. OK, yes. Thank you, Pedro. OK. So here we are. OK, so let's run this thing again. OK, so this -2 goes down. This goes up by 1. This goes up by 2. And if we reach 10, it stops. OK, so we push the button. It doesn't work anymore. We can have even it on the slide. So I can track red votes, because my demo didn't work. I can track yellow, and I can track green stuff. So this is all for you to saying it's simple to wire in what you have built doing with Johnny 5 and Arduino to the internet. There is also a very nice library. There is also a very nice library for Arduino called PubSubClient, which works very well. Well, let me say just a little bit of stuff to my MQTT broker. I've written an MQTT broker called Mosca. You can just use it standalone, which is what I'm using, or you can just use it inside your app. And you can use this for storing, I don't know, each message for a time series or whatever. Well, you can plug your authentication API, well, deploy it in very tons of ways. There is little documentation. Please help me, guys. It needs a database. Well, it's very important. It supports WebSocket natively, so well, it just works. It's kind of fast. OK. There is a test instance. This is me. I'm over time, so I'm not presenting myself. Thank you. And thank you, guys.
Thank you, Matteo. That was brave and successful. Thank you very much.
Thank you, Pedro.
Thank you. Thank you for coming. OK, so moving on. Our next speaker knows his Node.js deployments, building and managing large-scale Node.js projects at Walmart. He's a contributor to Happy.js and is here to tell us a bit about it. So please welcome Wyatt Pearl.
Hold on 1 second here. Here's the I'll full screen it over on this side. Way on the left. Oh, on the right. Do you see my cursor? Okay. All right. Sorry about that. I'm Wyatt, and the illustrations for this were done by Mohanad Jawadi, who's a friend of mine. And you can find me at jsgeek.com or on Twitter, GitHub at Wyatt Proul or W Proul. And I'm going to tell you a little story first. I was talking to a programmer friend of mine a few weeks ago, and he was telling me about this project he inherited. It was this legacy code base. It was a lot of spaghetti code. And so anytime he tried to fix a bug or add a new feature, it seemed to create more bugs elsewhere in the application. And anytime he tried to do a deploy, once he finally got a feature ready to go, the deploy would take pretty much all day to do. The tests that were there in the project were very slow to run. They would take minutes. And the application was just terrible. There were lots of performance problems. So if the application made a request to the database, it would take maybe 30 seconds if you're lucky. So it was a big problem, and he was frustrated. But he did know JavaScript, and so he decided he was going to rewrite the entire code base in JavaScript. And since it was a server application, he decided he was going to use Node. And so with Node, he was able to have a lot more fun and also leverage his JavaScript skills on the server. But Node didn't solve everything for him. He still needed a web framework to build off of. So he decided to use Happy, which is a web framework that we created, and it has lots of great solutions in it. It has solutions for doing routing, for authentication, caching, validation, cores, view engine support, and a lot more. So he rewrote it in Happy, and performance improved. His deploys were not a day, just maybe a minute. Testing was much better. So I'm not going to talk about all of those features that are pretty common in other web application frameworks maybe. I'm going to focus instead on some of the features that are more innovative, some of the features that I think are more useful. And one of those are how teams can work better together using Happy. We also have this concept of composable servers. And then we also have created extra tooling to make your life easier. So we have tooling for debugging and monitoring. So, obviously, whenever you're working on a large server, you want to work with other people. So one of the problems we have is how do we work together easily? So that's something we've tried to help solve. And one of the ways we do that is we have deterministic routing. So our routing table will always be sorted in the same order. So if you have a new developer coming in and trying to fix a feature, you don't have to worry about them interfering with your existing routes. All of the routes will be sorted by most specific to least specific. And you'll get an error before the server is even started up, So you don't have to worry about that. Another nice thing that we've added is validation for requests and responses. So if you have a new developer again, or just somebody on your team, quickly fixing a bug, you don't have to worry about them breaking a contract that you may have with a client. We have this response validation there. So in this example, you have the schema there on the response, and with just name and email, and we use a module that we created called Joy. And it's pretty expressive. You see, we have joy.string, and then we, like names required, emails required, and you can say like email is an email, so validate it as such. So this is something we do when we're doing development. We'll use the response validation just to make sure that we're not breaking anything. And then you also have request validation you can do. And what's really nice about Joy is it's also browser-fiable, so you can run it on the client. So you can have the same validation, on different teams. We agreed on this schema. Let's just make sure that we stick to it. And then the third way that we help teams work together is this concept we have called plugins. And plugins are pretty awesome. They allow you to extend happy features. So this is all you need for a plugin. It has a register function, and then just the name and version of the plugin. In this example, we're handling the internal error event. So anytime you would respond with a 500, we're going to log that to the console. Pretty straightforward, I think. And another nice thing with plugins is that they actually work very well together. So you can be explicit and say that my plugin depends on this other plugin. You can expose functions. So in this example, we're exposing a function called util that just logs something. And another plugin is able to then just use util from my plugin. So working across teams, this is nice. You can all deploy to the same server. All your plugins can work together. You don't have to worry about routes conflicting, any of that. And another kind of pretty, I think it's an innovative feature we have, which is this idea of a pack or kind of a composable set of servers with these plugins. So you can take these plugins and you can pack them together and then reuse them across different servers. So in this example, we have two servers. We have one listening on port 8000, one on 8001, and then we're registering two different plugins, Good and Reptile, and then we start. And that's it. You're starting both those servers with these plugins. And so we looked at this, and we realized that there's a little bit of boilerplate. So we removed the boilerplate. We kind of polished it up, and we realized after doing that, what we were left with was just configuration. So then we created this concept of, the pack, but then we have a CLI and this concept of just a JSON file for all of the configuration. So here's just a JSON file that has the pack, and we're creating a Redis cache that will be used across the servers. And then we're creating a server with listening on port 8080 and just adding some options to it. And then we're registering the same plugins we used before, Good and Reptile. And then you can start this with our CLI. So you just say happy, give it the config. And this is pretty powerful because it allows you to bring down all of your production artifacts into just two files. So we just have package.json and then your config.json, and that's it. And then that's production, that's QA. Pretty cool, I think. So we did all of that. Those are cool features. And then we also have been working on extra tooling to help developers have an easier time using Happy and using Node. And a common problem with Node and anything is debugging. How do we make debugging easier? So we have 3 plugins that I'll highlight here to help make debugging easier. The first one is Poop, which drops or dumps a heap snapshot whenever there's an uncaught exception. And then you can go use Chrome, the web tools, and analyze that. Then we have Reptile, which allows you to open a REPL on your server. So, if there's a memory leak or you're just kind of curious what's going on at a particular time, you can, launch Netcat or Telnet or whatever and into your server and poke around, see what's going on. And then we have TV, which is really nice for developers when you're just trying to understand how requests are related to different handlers. And this is a screenshot of TV. So you can see what requests are coming in and what data is going along with that request and how it's being handled throughout the application. So on top of the debugging tools, we also created a plugin called Good, which allows us to do lots of useful ops monitoring. So with Good, we log event loop delay, different memory usage, garbage collection counts. You can have request details and a lot more. And you can then log that to Redis, to Splunk, to files, wherever you want to go. And then what's really nice with having all of this data is that you can create some powerful dashboards. And this is a screenshot of one we created in Splunk. And you can just see just the volume of what you can do. So at the bottom we have, what do we have? Just memory usage, and then you can correlate it with requests coming in. So you could say, like why does the memory spike whenever I have this request coming in? And you can see, oh, well, there's garbage collection going on. So it's pretty powerful. It's really useful. So on top of all of that, we did create a nice tool for doing our testing. We were using Mocha and Chai and Blanket, and we kind of wrapped those into something called Lab, and then simplified it just to what we needed. And with Lab, we have built-in code coverage. We use Chai-style testing, and we use this to kind of push ourselves to get 100% code coverage on all of our open source projects, which it's like, yeah, 100%, whatever, but it's actually kind of hard to do. When you get to that 90% point, that's not so bad, but 90 to 100, that's a challenge. I challenge you all to try to do that, get 100%. That last 10%, you're going to find bugs, I guarantee it. So what's nice also about the code coverage we do have, it doesn't just look at lines of code covered. It actually looks through like your ternary operators and checks to make sure all conditions are covered. It'll find code that doesn't need to be there, so you can delete it. So at the end of all of this, we feel like we've created a pretty successful, pretty useful web application framework. And throughout this whole journey, we've helped fix some node core issues, find node core issues, like the infamous memory leak that we had. Our node Black Friday was a success. It was actually kind of boring for us. So this is a graph of our memory usage at Walmart running mobile.walmart.com during peak hours. Yeah, it's not that exciting, is it? And then this is our CPU usage. It goes up to 100%. We're all the way down here. It's like 2%. That's peak. So it was pretty awesome just not having to do anything that day. So if you're interested and happy, want to learn more, we have a workshop going on today at 5. Please come check us out. You can learn more at happyjs.com. Thanks.
Thank you, Wyatt. So our next speaker is coming from New York. She has one of the best job titles ever. She is an interactive news developer, where she joins two professions, a journalist and a front-end developer. She's working for the New York Times. Please welcome Brittany Storos.
Cool. Hi, everybody. Like Leo said, I am coming in from New York, and this is actually my first time out of the United States, so I'm super excited. Yeah, I'm excited too. So excited to be here and super thankful for the opportunity to be able to talk to all of you guys today. I work at the New York Times back in New York, and I'm on their interactive news team. And working in a newsroom environment, working on newsroom deadlines, when you're programming on these, you're going to learn a lot about yourself as a developer. And your strengths and your weaknesses as a developer are going to be magnified tenfold whenever you're on a deadline. So one thing a while back that I had learned about myself was that I wasn't the best at debugging things. I would be on a really tough deadline, and I would have to solve a bug, and it would just be, I would just freeze, you know? So I did my homework, and I learned dev tools inside and out, and I was doing really well. But one other luxury, actually, of working on the team that I'm on is that we have a very flexible tech stack. So we have the flexibility to work with whatever kind of frameworks and libraries that we want. But as great as that is for so many different reasons, that also means you might be debugging code in a framework that you've never worked with before. But lucky for me, we have lots of different dev tools out there for all the different frameworks that we can work with. So we have Batarang for Angular. We have the Ember Inspector, React Developer Tools, and the Backbone Debugger. And that's just to name a few. And as Wyatt was saying, making debugging easier is so important for developers. So being able to use these was super helpful when I was trying to learn how to get through different bugs in different frameworks and work through different problems. And they're all kind of more or less the same. They'll have a very standard set of features. Most of them are going to provide general page and library information. They're going to display some of the current MVC data that is in the application that you're inspecting, and they're going to keep it in sync. And they're going to track some life cycles within the framework. And you might also have some performance monitoring available to you to look at those kinds of things. So any debugger you come across, these are going to be some of the core features that you're going to want to put into these things. And the fact that all of these large client-side JavaScript frameworks have these custom debugging tools solidifies in my mind that having these tools isn't just a nice to have. They're actually kind of a necessity. So whether you're open sourcing a framework, or even if you're just working on a code base at the office, or if it's something that you're working on the side, having a custom debugger tool is going to help new developers understand the framework's intentions, but it's also going to help you expose areas for improvement in your framework. So within your code base, you're going to notice if there's a huge performance hit somewhere, you're going to see it right away in these debugging tools, or someone else will, and they'll be able to fix that performance issue for you. So today what we're going to do is actually create one of these in like 10 minutes. Let's go to some code. So if you've ever created a Chrome extension before, this file will probably look familiar to you. Can people see this code? Is that good? A little bigger? So this is just a manifest JSON file, and it's just going to set some configuration options for your extension. And the only thing that makes this different than, that makes a DevTools extension different than a regular one is this one property right here, this DevTools page property. And we're just going to specify an HTML page for our DevTools panel that we're going to create. But what's kind of wonky about this is we're not actually going to do anything with this HTML page except put some JavaScript inside of it. So the DevTools page isn't something that you visually need to see. It's just something that you need to have in order to run some JavaScript in the DevTools window while it's opened. And so this is our DevTools JavaScript. And the API for creating a panel in DevTools is actually super simple. We can just call Chrome DevTools panels create, and then we're going to pass in a couple of parameters. We're going to pass in a name. So for the sake of this conversation, we're going to be debugging a framework called Voodoo Black Magic. Thanks to Pedro for that name. Don't try to go looking for that framework. Don't try to put it in your projects. It's not real. So ignore that. We're going to have an icon, a URL to an image path, and then we're also going to have another HTML file, which is going to serve up the UI for our panel. We're going to have a callback that we specify, but let's first just go back to our browser and make sure that our panel is showing up the way that we are expecting it to. So when you're developing a extension locally, Chrome makes it super easy for you to load it up while you're testing it out by loading an unpacked extension. And from here, you can just select your folder with all of your extension files, and it'll add it to DevTools for you. And immediately, it will tell you if there are going to be any problems with it that are going to stop it from working. So it looks like we're OK adding this in. It's enabled. Let's open a tab and see if we have it in our DevTools. Make this bigger. Oh, no. Yikes. That's the little voodoo going on. That's what's happening there. So it looks like we got our panel in our DevTools just fine. But it looks like we don't have a Voodoo framework application running in this tab. So let's open up a tab where we do have one running. And I just made a very standard, a very token to-do application with my fake framework. And if we go to our tab, how does that look? Now we can see that we have a Voodoo application. We have some information about the version of Voodoo that it's running on. And it looks like we have some options to toggle a couple of views and inspect some of the data that we have in our application. So we're at a point where our panel is getting information from our inspected page. But before we can understand how that's happening, we need to take a look at the structure a little bit of how these are built. So a DevTools panel is going to have three main parts. The first one is the DevTools page, which we just created, where we have access to the DevTools APIs, and we can set up our panels and our sidebars, or whatever UI components we want to have. The second part of the structure is going to be this background page. And again, this isn't going to be an HTML file. You can just make it a background JavaScript file. But it's going to serve as our channel for communication between our DevTools panel and our inspected page. And the way that we interact with the inspected page is through content scripts. So content scripts are, again, just JavaScript files that run in the context of the inspected window. And they're going to give us access to a shared DOM. So whenever we want to do something with the DOM or we want to get something from the DOM, we can get that information using a content script because they share it. These do have a clean JavaScript environment, though. So you won't have access to the JavaScript variables in there unless you inject a script directly into the page. So let's go back to that callback function. That we saw a little bit ago. This is how we're going to set up this channel of communication with our background page. We have access to the panel that we just created, and we're going to call Chrome Runtime Connect in order to open up a port of communication between our DevTools panel and our background page. You can optionally pass in a name for it just to keep track of what connections you have opened. And then we're going to set up some event listeners so that we can grab messages from the background page and tell our panel what to do with them. We're also going to set up a method on the window of our panel so that we can send event messages back to the background page and update the DOM or interact with the inspected page in that manner. And then our background JS file. This code is actually almost so boring that I don't want to talk about it, but really quickly, we just want to listen to this Chrome runtime on connect event. And whenever that's fired, whenever a new connection is made, we add a listener to keep track of the port that we just opened, the port of communication that we just opened. So we're just going to add these ports to an array and hold on to it so that we have a good mapping of where all of these messages should be coming and going. And then again, we're going to set up some listeners for our extension. So when we get messages from our DevTools panel, we need to send these to a particular tab. And the way we're going to do that is either by executing a content script or just sending a message. And when we send a message, we also have to send along a tab ID so that it knows where to go. I don't know about you guys, but I always have like 100 tabs opened in my Google Chrome. So if they tried to figure that out on their own, where this message was supposed to go to, it would take quite a long time. And then lastly, we're just going to handle some incoming messages from our content scripts. And we have a function down here, send to DevTools, that will send this right back to our panel so that our panel can update when something happens in the DOM or when we're interacting with our application. So let's do 2 quick examples that kind of illustrate this concept of message passing for these DevTool panels. First, let's do a message from our panel to our application. And if we look at these toggles right here, let's take the first one, for example, show view outlines. Let's say when we toggle this checkbox, we want to outline all of the views in our application so that we get information about them right on the DOM, and we can see it really clearly where all the views are and what their data is that's associated with them. So setting something like that up is as simple as putting an onChange event on that checkbox whenever we're toggling it in the panel, and then sending a message to the background page. So we set up this method earlier when we first created the panel so that the panel would know how to send something over to the background page to get it to a content script. And we're just going to give this event a name. We're going to say toggle view details. Again, we're going to pass in the tab ID so that the background page knows where to route this to. And we're just going to send in whether or not that checkbox is checked, whether or not the DOM should show this information or not. And then by the time that gets to the content script, we have a listener on our content script that's just going to check the message that was just sent. This is a little more hard-coded than it should be, but for the sake of just showing an example, I figure this is a little bit easier to explain. So once it gets this message that has information about toggling view details, we're going to call a function update view details. And this function is just going to be plain vanilla JavaScript that's going to add our view information. Oh, more voodoo, more magic. It's going to add our view information to the DOM, to each of the views that are in our DOM. So when all those messages are hooked up together, when you toggle this, we can get all this data about our views on this side. Let me make this a little bigger. So we have one view that's just our add to do view. We have the controllers that are associated with them. Let's see if I can make that bigger. And then we have our list view, and we also have a single to-do in here at the moment. So that's how we can kind of manipulate the DOM, and you can check this and uncheck it all day long if you want to. So let's do one more example where we want to communicate from the inspected application to our panel. And we have this list of views down here in our panel that show us the current views that are on the page. And every time we add a new to-do item and we add a new view to the DOM, I want this table in my panel to update with that as well. So if you happen to look through the source code of other debugging tools, other debugging panels, everyone kind of implements these things in a very different way. There is endless possibilities for doing something like this. But basically what we need to do to get that done is make sure we're listening to what kind of data we have, what changes are happening in our data in our application. And if you're super excited about ES6 like I am, I'm just setting up an object observe on our views so that whenever a view is added or a view is changed, we're going to call this dispatch change messages function or method. So we're adding this method directly into the framework. As long as this code is injected into the application page, we'll have access to add this method directly to the window or directly to our framework. Obviously, we should be doing a check to make sure that it is not already there, it doesn't already exist. But when it does this, we're firing a new custom event called data change. And we're going to dispatch that on the window. So every time that happens on the window, our content script is going to be able to listen to that. And every time that happens, we'll send a message to our background page saying that some data was updated. What should we do with this? And going back to our background page, we know whenever we get these messages from our content scripts, we're going to send them right over to DevTools to let them figure out what it is, what kind of message it is that came in, what they want to do with it, and how they want to react to it. So when this message comes in, let me find this. When this message comes in and it makes it to our DevTools panel, we're going to try to handle this inspected window element. Or event. We're going to handle an event that just happened in our application. And again, this is more hard-coded than it should be. But we're just doing a check to see if the event was an added view. And if it was, we're going to update this views list that we have. And the function here for this, all it's doing is grabbing the most recent view that was added in our framework and appending it to the table that we have in our panel. One thing to note about this code is this line right here. You'll notice it says eval, and we're all very scared of eval. We're terrified of that, right? But when you're creating a DevTools extension, you're almost always going to need to use this at least once. Your DevTools panel has limited access to the inspected window. So like I mentioned before, we can get the tab ID of the inspected window. And the only way we have access to the JavaScript on that window is through an eval. So you have to be really careful using this. And you have to know what you're doing with it, obviously. But this is why when you install an extension, it might be asking for like 1,000 different permissions. And it sounds terrifying to install it. But that's because that's how powerful this is. But we need to use this eval so that we can get our object of views that is currently in our framework and pass that back to our panel. So when this is all hooked in and we have our most recent view and we have that data available to us, every time we add a to-do, it should add to the bottom of our table right there. I have a lot of lorem ipsum memorized. I can continue doing this, but I'll stop. So those are just two very trivial examples of how we can communicate from our panel to our inspected page and vice versa. Obviously, you can do a lot more with these things, and debugger tools are a lot more comprehensive than something like this. But that concept of message passing is what you really need to get a hold of in order to build something full on for a debugging tool. Hopefully, this gives you guys some ideas about tools that would be useful for you or things that might be helpful for you when you're debugging. And we will, there's tons of like documentation and really great stuff on the Chrome website to help you start building out some of these. I would also strongly recommend looking through the source code of other debugger tools, because they're all pretty involved and have good examples of how you should build these things. Presentation is this second link. Second link to the bottom. I'm Brittany Storos everywhere on Twitter, on GitHub, and I will be posting the code to this on my GitHub, hopefully after lunch. So look out for that when I tweet that out. And thank you guys.
But unlike me, he puts his money where his mouth is and works for Pearson Higher Eds, where he is the chief architect of innovation and advanced development. So he works every day to making education more affordable and accessible and practical. So from Colorado, Denver, Colorado, USA, please give a warm welcome to Mike Brevoort.
Hang on. Let's see. This to work. All right, that's good. There you go. So I didn't realize that GitHub stickers were such an amazing social currency. I think someone almost punched me in the neck over there. It's amazing to see people go after GitHub stickers. So, so thanks for having me here. Again, my name is Mike Brevoort. I, like many of you, develop software for a living. But today, I'm giving a non-technical talk, for the most part, on education. So I was very happy to see a litany of technical talks leading up to mine. So I work at Pearson. We're the world's largest learning company, where we have a simple mission: to help people make progress in their lives through learning. And I believe as software developers, we really have a unique opportunity to improve people's lives through learning. So thanks again for having me back here in Lisbon. Thanks, Pedro, and David, and Nuno, and everybody. It's just really been amazing. So I want to start off with a little bit of perspective. There are 253 of us or so here in the audience from 24 different countries, which is just amazing to me. Now imagine if all the people in the room represented the population of the entire world. A third of one of you would live in Portugal. 26 of us would live in Europe, 40 of us would live in Africa, and 28 of us have no access to clean drinking water. 31 of us are hungry or malnourished, and only 101 of the 250 or so of us even have access to the internet at all. That's 40%. So good thing to keep in perspective. And only 17 of us even have a college degree. So relative to the rest of the world, all of us here today are privileged. And if you lined up the 253 people here that represented the world's population, from the wealthiest to the least of these, we would really be in the front of that line. And I say this not to make you feel guilty, but to give you some perspective. You know, in fact, most of us had no choice in the matter at all. Did you know that the most significant factor in determining your place in this world was your parents' place? That's right, our parents' prosperity is the world's greatest predictor of our own prosperity. And so, if we're destined to follow in our parents' footsteps, to follow in the path set out for our parents before this, how do we rise above? How does one live a life more fruitful than that of their parents? And in the same, more pressing vein, how do we enable our children to lead a life that exceeds our own prosperity? This is really the desire of every parent, is it not? To see that your children are afforded the opportunities in this world that you lacked. And so by far the most predictable way to outrun your own destiny is through education. And education is fundamental. The ancient Greek philosophers believed that education was a lifelong process of drawing forth the full potential that lay within. And education is the most powerful life catalyst in the world. Nearly every factor of prosperity of people and communities positively correlates to education. For the poor, education is the most promising route to a better future. It prevents the transmission of poverty between generations, and children whose parents have little or no schooling are more likely to be poorly educated themselves. Education is one of the most powerful ways of improving people's lives and health, and of making sure that the benefits are passed on to future generations. For example, basic awareness of proper sanitation and the use of mosquito netting goes a long way to prevent the spread of disease. In the world's poorest countries, a child born to a mother who can read is 50% more likely to live beyond the age of 5. And education promotes tolerance, trust, and helps people understand democracy, and motivates them to participate in politics. It plays a vital role in preventing environmental degradation, and education can empower women to overcome discrimination and assert their rights. For many looking for a way out, education is the only sustainable road to a better place. However, there's a stark and significant gaps in access and opportunity. Worldwide, there are 57 million primary school-aged children who are out of school. These children are often forced to leave school due to the need to earn money to support their families. Girls are often forced into early marriage or bonded labor, and the basic costs of education can easily consume a poor family's income. And the costs only grow as students age, and cost isn't just a third-world problem. So, for instance, between the years 2001 and 2011 school years, the price of an undergraduate tuition at public institutions in the United States rose 42%. That's 42% adjusted for inflation. So in other words, the cost of a degree has nearly doubled in a decade. And also in the United States, the average student graduating with a bachelor's degree has accumulated $33,000 in debt. In fact, in the US, it's no longer possible to work your way through school without accumulating a significant burden of debt. Meanwhile, the value of a degree is falling. The average lifetime earnings for a full-time worker with a bachelor's degree has decreased 1.6% annually since the year 2000. To further complicate things, the education system of the 20th century is quickly becoming outdated. Before the age of information, before the web, schools and teachers were gatekeepers of knowledge. Lecturers and the university library had a monopoly on information. And for thousands of years, content and information was a scarcity. But today, it's a vast, unwieldy, accessible commodity. And the system of education developed for the Industrial Revolution was steeped in discipline, uniformity, standardization, and memorization. Information alone was precious, and regurgitating it was valuable. Students were taught to respond with the correct answer, and creativity and critical thinking were implicitly unrewarded. But the world is changing, the economy is changing, the monotonous jobs of yesterday are being consumed by technology. But conversely, new opportunities emerge. The 21st century knowledge worker needs to be dynamic, adaptive, always learning, and entrepreneurial. Students with a university degree are no longer guaranteed a job. And there's a growing gap between the skills employers require and the skills of today's graduates. In other words, new graduates are struggling to find jobs, while employers are struggling to fill entry-level positions. And the Organization for Economic Cooperation and Development states in a recent report that countries need to provide good basic education in childhood and adolescence that equips people not just for the jobs of today, but for the ability to learn new skills for the jobs of tomorrow right through their lifetime. In other words, it will be more important that students learn to learn and form a disposition to learn and create and do to stimulate lifelong learning. You know, one of the interesting changes that's happening in post-secondary education is the unbundling of sorts. For example, the unbundling of a degree program from the research function of a traditional university. There's also an unbundling of degree programs themselves. Why shouldn't a student be able to choose which courses to take and from which universities or instructor, whether in person or online? And what is so magical about the 4-year degree anyway? Is a Bachelor of Computer Science degree more reputable than a list of courses with certifiable completion, including data structures and algorithms, machine learning, natural language processing, web development, and the like. Students should be able to choose their own learning paths and build their own portfolio and make sound investment decisions on a course-by-course basis. And we're starting to see that happen. Also, why do we front-load education? Why do we spend the first 20 years of our lives in classrooms and the next 40 in a workplace? It sounds a bit waterfallish, doesn't it? We're going to spend the first third of our lives preparing and anticipating for what skills we'll need for the next 20 or 60 years from now. As if nothing in the world will change. We should apply the same agile and iterative development techniques and principles to education. We should embrace a lifelong iterative approach to work and learning. Which brings us to an overwhelming question: what can we do? These problems are large, systemic, and overwhelming, and there are many policymakers and institutions searching for solutions. But I think real, meaningful, impactful change will not come from the top down, but rather from the bottom up, from a groundswell of purposeful innovation. And so by now, you're probably wondering, what the hell does this have to do with JavaScript anyway? Well, in some ways, not a lot, but I think that JavaScript is the language of the web, and the web is the infrastructure for change. And I believe that education will be revolutionized through the web. Learning is such a pervasive yet personal common ground. Education has impacted us all in very unique ways. And I believe that most of us want to help, but we're either too busy or just don't know how. So I ask you to consider your own experience for a moment. Think back over your life about what was most impactful to you about your education. What were the pivotal, life-changing moments that shaped your life? And what do you remember about them? Can you think of something? Don't worry, I'm not going to ask you to stand up, or I'm not going to ask you to shout out your answer here. I would love if you shared with me maybe later today. But for most of us, I would say, most of us, when we visualize these moments, I bet you don't see a textbook. I bet you don't see a school or a building or a computer screen for that matter. I bet you see a person. And I bet you had a connection with that person, a relationship. Maybe not very deep, but you had a connection. And I bet that person was instrumental in making you believe that you belonged, that you were worthy. Maybe they helped you unlock your passion, identify your purpose. And most of all, they made you feel like you could do it, that you could do it, which is so important. And maybe this person was a teacher, a parent, a coach, a mentor, a leader, a classmate, a coworker. All these people have one thing in common. They're just people. Like you, seriously, we're all just people trying to find our way through life. And if you think back to that pivotal moment, and I bet if you asked that person if they remembered that time, and if they knew how important it was to you, that they may not even recall it, or at least had no idea of the magnitude of impact that it had on your life. Most times we think of teachers in the formal sense. But did you know that every day you were teaching? We're all teaching others how to interact with you, how to deal with you, modeling for others how you deal with situations by how you deal with situations, teaching others how to respect or disrespect each other by how you treat them, online or in person. Do you know that you have a profound impact on the lives of others around you? In the most unpredictable and seemingly unmemorable ways. Transformation in education will happen through teachers. So we must invest in teachers. And remember that we all have the capacity to be teachers. So the goal for Lxjs this year is to encourage new developers to learn about new tools, frameworks, and technologies, becoming leaders in their local area, empowering their community. Well, a lot of times we're all new developers. We all have something to learn. But we all have something to teach. Every single one of us. And the difference between those people in your lives that impacted you and everyone else was that they invested in you. So I ask you today, who will you invest in? As software engineers, designers, developers, computer scientists, regardless of how you identify yourself, We are all in a unique position. We are beneficiaries of education. It has enabled our livelihood and given us incredible opportunities. But we are also creators, makers, inventors. Like industrial manufacturing engineers who create the machines that make the machines, we create tools that enable others to create. We create tools for teaching and learning. We can create new ways to disseminate information, new methods of collaboration and group work, new adaptive, personalized learning experiences, and we could help democratize education. More than any other profession, I believe we each have the power to change the world. This sounds very sensational, doesn't it? Don't believe me? Take Salman Khan, the founder of Khan Academy. Not the Indian actor, though. I'm sure he's fantastic. But in late 2003, and they look very similar, actually. I mean, if you go back and forth, they look really similar. It was amazing. I had no idea that the other Salman Khan exists, but he's very popular. So in late 2003, Sal Khan began tutoring his cousin Nadia in mathematics from afar over the internet using a Yahoo Doodle notepad. Soon, other relatives and friends sought his tutoring as well, and he began publishing his tutorials to YouTube. Today, Khan Academy videos have been viewed nearly 500 million times, and Khan's goal of helping out his cousin has grown into a life mission of changing education for the better by providing a free, world-class education for anyone, anywhere. Sal Khan was not a professional software developer, but he leveraged the tools and capabilities made possible by people like you and me, and Khan Academy employs many developers today. This is one example of a person who took an interest in the learning of one other at the time, and is now using technology to literally change the world. Is it Salman Khan or technology that is having such a profound impact? I say it's Salman Khan through technology that is making a difference. He is a teacher. He wasn't even a teacher. He was a hedge fund manager. And now he's a teacher amplified by technology. And the value of education is learning, not instruction. Teaching is irrelevant if no learning occurs. And such technology and education is irrelevant if no learning occurs. We must temper our estimations of the impact technology alone can have on learning. Technology will never replace the teacher. And technology should never replace the classmate. Even with fantastic advances in artificial intelligence, we as humans crave bonds with other humans. We are social beings, and it is in our nature. As Simon Sinek describes in his book, Leaders Eat Last, there are two chemicals in our body, our physiological makeup, that reinforce social behavior: serotonin and oxytocin. Serotonin is responsible for the feeling of pride, accomplishment, and fulfillment in ourselves, and more importantly, in others we care about. When my daughter first learned to somersault or tumble, she would say, "Daddy, Daddy, 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 look," trying to get my attention. "Daddy, Daddy, Daddy, look," waiting for me to look. And as I glanced over, she would throw her head down and her heels over her head, and she would roll through, looking to catch my eye, waiting for me to look back, beaming at me with pride. And I would look back at her, super proud, right? And say, "Good job, honey." And as we did that, we both got a boost of serotonin through that relationship. And it was so important that I watched her. I mean, think about your own experiences, right? The difference from doing that alone and doing it within a group. This sense of fulfillment and pride occurs through the lives of our kids as they graduate from preschool, kindergarten, high school, and they graduate university, as they show us their report cards and so on. The bond occurs with teachers and mentors and coaches as well. We share in the accomplishments, live vicariously through others, behaviors enforced by serotonin and our own human physiology that technology just will never replace. Oxytocin, on the other hand, is released within us through physical contact, a hug or a handshake, and even the image of another human being we care about. It's released reciprocally with acts of human generosity, and when others use their time and energy for our good. These human bonds matter. Technology should not try to replace the human, not try to replace the teacher, but instead amplify the teacher and enhance the learning experience and get out of the way. There's one more example I'd like to tell you about that I just love. It takes two needs, one that perfectly serves the other. The CNA language school in Brazil has created the speaking exchange. It started with a simple idea. There are many young Brazilians learning English who need conversational practice, and many elderly Americans living in retirement homes who are lonely and just want someone to talk to. So let me just show you a brief glimpse of what they did.
We created a tool that connects our students with seniors in the USA living in retirement homes.
Hello, hello.
Melissa.
Hi, Dick. Can you hear me? Yes, I can. Can you hear me?
How are you today?
I'm good. How are you?
It's the first time that I'm talking with someone from another country.
I'm very excited to be doing this.
I look like I'm only 25, but I'm 88.
Do you have sisters and brothers?
No, I'm one child.
Only one? Oh, you poor fella.
I live with my old brother. He has 23 years.
Do you know, instead of saying he has 23 years, you could say he is 23 years old.
I want to thank you for this change of experience, you know. You are incredible.
Obrigado.
It's just amazing, right? So these relationships, these bonds, are actually reinforced by a little boost of oxytocin. It's amazing what technology can do, even when it just gets out of the way and links people together. So there are two things that I want you to do, that I ask you to do. The first is invest in others. Not your money, but invest your time and your energy. We stand near the front of the line, and we are so fortunate to be able to do what we do for a living and to live the way that we do. Instead of clawing your way further forward, turn around and pull someone up. And whether it be family, a neighbor, someone in your community, or someone on the other side of the world, share what you've learned freely. Pouring into others is never a bad investment. And remember, we're all teachers. And the second thing is to go and create and to make and invent new ways of connecting people that improves learning and that improves people's lives. If only for one person at a time. Don't expect that your government or school officials will take care of this for you. If we are to truly democratize education, we the people who are capable and care enough must act. You're all fantastically talented. I'm humbled to be here. Don't hoard your gifts. Pay them forward. Imagine the impact that we can make in education and the lives of people around the world if we did. Thank you.